Welcome, fellow Nixons, to NixCon 2020 Online Edition. Please welcome your host, Robert B.
Hello, everyone. I'm so happy to be here. Good evening, good morning, good afternoon, wherever you are on this planet. Hello. My name is World of Peace. You probably already heard that from the Cyborg Diva introducing me. So a little about me, if you're not already familiar from interacting with NixOS community. I am non-binary and my pronouns are they, them, and I've been using NixOS since 2018. And when I made that transition, I was just immediately enamored with this great sense of intuition that this was a perfect place for me. It really was the community that drew me in. The things I've achieved in NixOS, aside from being one of the top contributors for a couple releases, have mostly been collective wins, and I do like it that way. And I was co-release manager for NixOS 2003 and for the to be released 29, and I'd like to think I changed up lots of stuff for the better. And just lastly, generally within the NixOS community, I try to be a leader and show everyone pathways to kind and compassionate interaction. And from the response I've gotten, I'd like to consider myself as a very welcomed, accepted, and appreciated member. I try my best to return everything I've been given tenfold, leaving as many sparkles around as possible. So with that introduction out of the way, let's talk about the intentions behind why we're all here today. NixCon is a conference to share the joy that Nix has given us, whether it's in your personal projects, using it at work, or just being a part of the community. I've heard so many stories, and I've never seen a community having such impact on people personally. There's really something special here, and today is our opportunity to also broadcast that as far as possible. Though usually we'd be doing this all in person. An event for people to gather and actually see and hear these people in a tangible experience. But unfortunately, as you probably can tell, it wasn't a feasible option this year with all the travel restrictions because of the impact of COVID-19. But, however, I don't think you should take this as a tragedy at all. I see it like having this conference in an online setting is just another option. And like anything, it will have its upsides and its downsides. While it may come with not being able to share a physical presence, this gives an opportunity to those who can't travel internationally the ability to participate. And for those who can travel, you're going to have access to the event without needing to board a plane or try and navigate some country that you've never been to before. This is anytime access without any giant carbon emission. I hope everyone can see this as a great opportunity. And if we could all just together take a moment collectively to release any attachment you have on the outcome of this event. So me and the organizers have done basically the maximum amount of planning that we could do. But even then, we still can't control absolutely everything. And neither can you. Whether you're a speaker focusing on the delivery of your talk, a viewer hoping for an experience similar to that of a physical NixCon, or my dear organizers who so greatly just want things to work out smoothly. These are many variables but they're all like free to mutate. And maybe it's cool to actually be like a mutant. So instead, please turn your focus onto the process. This is for us. Let's all be selfish because it's okay to be selfish and share this fun together. We get to create this singularly defined moment together, traveling out into the internet and onto the minds of others. It's always up to you what something means. And for something to feel special, it has to mean something special to you. I really hope you all can consider this at heart and just surrender and undo and just let it mean something special to you. Okay, so with that out of the way, I want to share all the logistics to the viewers about the conference and like sort of the features. So we'll start with the overall schedule and the event flow. So you will see it on nixos.org. There should be a link to the schedule where all the talks are going to happen. And the exact structure of a talk is it's going to be 25 minutes, and the last 5 minutes are going to be a Q&A that is 5 minutes long. But it is also possible that some speakers may eat into their QA time, and I believe we have one who wants to answer talks interactively. And you can participate and ask questions in IRC, and I believe in the Jitsi chat. And the IRC chat is also bridged to Discord, so you can use the channel on Discord as well. And if you experience any technical difficulties, please contact at mbotham. They will be in the Freenode channel. #NixCon. And after our talk elapses, our moderator is going to be sharing the breakout room link for each talk when they end. And we can hopefully, since this was actually planned last minute, the part with the breakout rooms, direct the speaker into those rooms. So I'd also like to thank the viewers. Thank you for tuning in and being here with us. This is a first time event being an online NixCon. So thank you for taking a chance on us. I'd also like to thank my organizers once again. Thank you so much. They've been basically, I would say one of them has not slept, and I maybe slept for maybe 3 hours. And lastly, the people who really, really helped us be able to have this infrastructure. Without these sponsors, this would not be happening right now. So I'd like to thank Equinix Metal, Relational AI, Tweeg, nixbuild.net, and also Mutable, who has a sponsor perk, which we're going to transition to a little statement from Edith, the CTO, who actually organized this with us. So yeah.
Hello NixCon, I'm Edith, CTO of Mutable. We're building the public edge cloud to deliver a faster and more reliable internet by acting as an Airbnb for servers. Our platform spins up workloads where they're needed, when they're needed, and turns idle data center capacity into ubiquitous computing. We're proud to support NixCon again this year, and we're very impressed with how the Nixos community has grown over the years. We're looking forward to that carrying on. Nix and NixOS help us deliver consistent and reproducible software distributions to the diverse infrastructure we operate on, and are important components making our mission possible at all. It's the glue that ties together our entire internal development and deployment strategy, making it easy for us to keep evolving our stack and stay true to our name. We're truly humbled to have the chance to support such an inclusive and innovative community, and we're looking forward to seeing the impact of this year's NixCon. If you want to grab some of our swag, we've got shirts and stickers over at mutable.io/NixCon. Enjoy!
Hi, okay, with that out of the way now, we can proceed to the first talk. So I will mention that in order for me to do this, I have to sort of jump from Jitsi room to Jitsi room, so there may be a brief 10-second interruption. Sorry about that. Okay, we have our first talk here. This talk is called Nix Modules, Improving Nix's Discoverability and Usability. So our speaker today is none other than Ilko Dolstra. I think he's honestly one who wouldn't really need an introduction because he is the creator of Nix. So let me go over the topic of this talk. This talk is about Nix's configuration language, and it's very powerful, but suffers from a lack of discoverability, usability, and consistency. In this talk, Ilko is going to describe an experimental Nix module system that provides a consistent discoverable mechanism to write configurations such as packages and NixOS systems, and show how this enables a better user experience for both new and advanced users. And I would say Ilko's current work setup is that he is a senior engineer at Tweeg.io, and he joined that in 2018. Okay, great. Ilko, take it away.
All right, can you hear me?
Yep.
Okay, great. Yeah. Let me so start my screen sharing. So unfortunately, it appears that in Jitsi you cannot share a screen and video at the same time, at least not without the video becoming horribly blurry. So Sadly, you won't be seeing me for the rest of the talk. Okay, so in any case, thank you all for that. Thank you, World of Peace, for the introduction, and a big thank you to all the organizers. So yeah, of course, a slight downside compared to a physical NixCon is that I have no idea who I'm talking to, whether I might be talking into a void, but I'll just imagine that all of you are here. Yeah, so this talk is about, yeah.
Just interrupt you one moment. It seems that at least with our infra sort of status on your slides and your screen share, I cannot actually see it. So do you think you could toggle that on off? I'm sorry to everyone watching.
Yeah.
Okay, so tell me when you toggle that again, and I will get a confirmation that they can see that. Okay, give me 1 second.
I have toggled it.
Can you please check the second slide? How does it shows on the live stream?
So I'm now on the second slide.
Okay, I believe that your screen sharing is working. You can go to the first slide and begin your talk. I'm sorry about that. It just doesn't seem to appear to me, but it is working in live stream. Okay, proceed.
Okay, well, I'll monitor the comments here. So yeah, just let me know if it stops working. Okay, so yeah, this talk is about a bunch of sort of brainstorm sessions we've had, or I have had together with a couple of other people, in particular Rock Garbas, on how to make Nix more beginner-friendly and more user-friendly. Now, so the warning, this is quite a lot of vaporware in this talk, so most of the things I'm describing actually do exist. There is a sort of proof of concept of the things I'm going to talk about, but it's very far from being ready for actual use, let alone merging. So this is all kind of an exploration of some ideas on how to make Nix more user-friendly in various ways, but I mean it's very far from being in a state that you can actually use. Okay, so with that having said, let's talk about what the problems are with Nix currently. So Nix is, of course, it's awesome, but it's not very beginner friendly. There's a very steep learning curve. So you have to learn all these new concepts like immutability and Nix store and Nix expressions in particular. That's the big one. There's this kind of strange language that you need to learn, especially if you're not familiar with functional programming. And yeah, that's a steep learning curve, and probably a lot of people never get over that curve, so they just go away and give up. So maybe we can improve that. The second issue is that even if you are over the hurdle, you're an advanced user, there are actually a lot of things about Nix that are just not that great to use. In particular, Nix is wonderful in how possible it makes to adapt packages and configurations. So there's probably no other package manager where it's so where it's even possible to just say I'm going to rebuild my entire system with a patched version of GCC, or I'm going to set up a developer shell with these packages, but in some random combination and with some patches applied and compiled with these versions of the compiler. So, I mean, that's really great about Nix, but those configuration mechanisms are, for the most part, not easily discoverable. So you need to basically Google about them to find out that they exist, how you use them. Yeah, another problem is there are actually a bunch of configuration mechanisms, and they all work in slightly different ways. They're often not very easy to use. So what can we do about this? So in this talk, I will discuss adding a more uniform, sorry, there was a comment. So we're going to try to provide a more uniform and discoverable configuration mechanism, make things more discoverable from the command line, and maybe, and this gets a bit controversial, provide a simpler configuration language like TOML for simple projects. So that would make the hurdle a bit less big for beginners. So a quick look at the configuration mechanism in Nix packages and what the problem are. So you have function arguments, .override, config, overlays, NixOS modules. So all these things have sort of grown organically over time, and they're all slightly, well, they serve different use cases, but it's not clear, for instance, why for NixOS we use these modules, and for packages we use this function argument style of configuration. In particular, the function argument style, that's this style where you write packages as functions that take a bunch of arguments like the dependencies and user configurable things like CUDA support. So this is the Nix expression for Blender, which you can enable CUDA support. So if you build this thing, so if you want to have Blender with CUDA support, there's actually no way to find out that this option exists except by reading the source of this Nix expression. So it's not discoverable at all. And once you have discovered that this option exists, maybe by Googling about it, how do I enable CUDA in Blender, you can't actually use it from the command line. So you might think that something like Nix build Blender arc CUDA support true does the right thing, but it doesn't, because that argument doesn't get propagated all the way down. Other problems, there's no type checking. It's kind of ugly that it mixes user-facing configuration with dependencies. So this is not a very great configuration mechanism. Now, we have .override. I won't go into details, but .override is another of these things that grew kind of organically. It has all sorts of problems. It's inefficient because you need to, under the hood, it calls a function twice just to get this .override function. And it leaks memory. So if you're wondering why Nix evaluation takes multiple gigabytes, well, this is one of the reasons. Yeah, then there is the Nix packages configuration file, so you can put things like this inside a config file. But again, it's not discoverable. There's no type checking. It's not obvious how you use it from the command line. So yeah. Now then, finally, there's overlays. Overlays are great, but the syntax is kind of mysterious. And it's also not obvious how things like nested overrides work. So if you want to override something at top level, it's easy. If you want to override something deep down, like in Python packages, it's not obvious how it works. And then there are NixOS modules. And NixOS modules are great. They're awesome. So they basically tick off most of the boxes. They're discoverable. You can just type man configuration.nix. They have documentation, they have types. I mean, there are some problems, and they're entirely a library feature. So Nix, the command line tool, doesn't know anything about them. So you can't easily query NixOS options from the Nix command line or set options or do things like that. So, yeah. Okay, so let's... As a solution, since NixOS modules are so great, maybe we can just use NixOS modules everywhere. So turn NixOS modules into a language feature, maybe make some improvements, like clean up the syntax and the semantics, and then use it everywhere. So instead of, for instance, having functions that create packages, we can have modules that create packages. So here's an example of what that looks like. So this is a module that builds Hello World. So if you know NixOS modules, then the syntax is probably familiar. Probably we would actually want to improve this syntax if we really turn this into a language feature, because then you're no longer confined by having to have these weird constructs like having config as a function argument and as an attribute name. But apart from that, it should look familiar. So what this module does is it extends a bunch of other modules like standard env. So in this modular world, we no longer have a function called standard env.make derivation. Instead, standard env is a module that you can extend or inherit in your own modules. And that should, in theory, make it easier to combine modules. So, for instance, if you have a package that both includes Rust code and Python code, you could just include the module for building Rust and the module for building Python. So, what this module does is it says hello world by default, but the text of the greeting is configurable at compile time. So it has a who option that you can set at build time. And that option is used in the configuration of this module. So the configuration sets a bunch of options that it inherited from the standard env module and the package module, like the package name, the version, the build script, and that build script then generates a hello world binary. All right. So how would you use this? Well, basically the same as how you use Nix now. And so, by the way, I should mention that this is intended to be part of a flake. So modules.hello would be a flake output. So just as a flake can have packages now, it can have modules. So if you say nix run.hello, that will build the hello module from the flake in the current directory and run it. And that's actually equivalent to building and running modules.hello.final.derivation. And derivation is an option inherited from one of these modules that we're extending, like standard env. That evaluates to a derivation graph. So just like in NixOS, you have an option called system.build.toplevel, which builds your entire system. Here we have an output option called derivation, which returns the derivation for your package. Okay, so the whole point was to make things discoverable. And now we have that because we have a standard structure and we have options that have descriptions and types. Actually, we don't have types yet, but we could have them just as in the NixOS module system. So yeah, we can discover via command nix list options, and that will show us all the options in this package. So for instance, this is how we discovered that this thing has a who option. And then we can override this from the command line. So we can, for instance, say nix run hello, and we can override who and set who to NixCon, and that will build a new derivation and run it. Now you might be thinking, aren't flakes supposed to be hermetic? So you can't actually override something inside a flake. So what this actually does is it on the fly, it constructs a new flake in a temporary directory that imports the flake in the current directory. So basically, it generates something that looks like this. And this is what you would write yourself if you were trying to extend the module. You could have a flake with a module named myHello that extends the hello module and sets NixCon to who. So this is basically the replacement for the .override or .override derivation mechanisms. Another nice thing to mention is that we now have a documentation mechanism, a standardized documentation mechanism. So there is a command called nixdoc that, given a flake, generates the documentation for that flake, just like cargo doc. It actually uses MDBook, which is also what cargo uses. So it takes all these markdown doc strings of all the options and modules and generates documentation out of them. So the goal here is to have a standard, uniform configuration or documentation mechanism for all flakes. So in the future, you should be able to say nixdoc on any flake and get documentation out of them. All right, final thing to mention is the beginner friendliness. So if I go back 2 slides, so this Nix expression, there's a lot of mysterious code in here, like this whole self hello stuff, this config thing over here. So that's might be daunting for new users. And in fact, it's kind of unnecessary, because with modules, modules are really just name value pairs like who, NixCon. So you don't need the whole Nix expression language just to customize a module. So the idea is you can just write a TOML file. You still have to declare your flake dependencies, but then you can say who is NixCon. And of course, we're extending a certain module, and that's it. So yeah, you could have a more user-friendly syntax. And another advantage of a simpler syntax like TOML is that this is easier to generate. So we can have a command line mechanism to modify a flake. So we can just provide a command to set options or add dependencies to a Nix shell or things like that. And that's less error prone than telling new users that they need to edit a Nix expression and get the syntax exactly right. So that's the idea. All right, so that's it actually. So the next steps that we're interested in doing is, well, actually try to improve the syntax and semantics of this toy module system, because right now it's an extremely bare copy of the module system that NixOS has, and it has no types or merge functions or stuff like that, so it's extremely bare. But yeah, so we'd like to come up with a better syntax and semantics and improve on the NixOS module system. For instance, it would be great to actually have sort of proper scoping. So for instance, a module should not be able to access options that it hasn't explicitly inherited from another module. And of course, we need to do a lot of experiments to see whether any new mechanism actually meets all the current use cases for the currently existing configuration mechanisms. I mean, so stuff like overlays or package sets. Yeah, we need to see whether we can actually do that. Okay, so yeah, there is a proof of concept implementation, but so it contains all these commands like nixdoc and nixlist options. So you can actually play with it, but it's very bare at this point. And there are actually some examples that you can check out. And there is a document somewhere that has more ideas about these language changes. All right, that's it for this talk. I understand I can now answer questions, so I need to figure out where I can actually see the questions.
Hi, so I will just read those off to you.
Great.
You are running early, so your Q&A will actually have 2 extra minutes if you want. Okay, let me read the first one we have in the pad. So this is from Andy on Freenode, and it says, what is the cost of having more features that other language already built into Nix?
Sorry, can you repeat that? I didn't quite catch it.
Okay, I can repeat that. What is the cost of having more features that other languages already built into Nix?
What is the cost? Well, obviously there is a cost in terms of we have to implement it. It makes the language more complex because, of course, the existing language features don't go away. But I mean, there's also the cost of not having this. So if we don't improve sort of had things like discoverability, we might lose a lot of potential users. So I more see it from that perspective. I mean, all of this is motivated by thinking in terms of use cases. So if a user wants to, say, set up a Nix shell, what do they need to write? And currently, if they, for instance, want to write a flake for their project, they have to write a lot of boilerplate code just to get that to work. So then you need to think about, well, what would an ideal Nix expression look like? Or maybe you don't want to write a Nix expression at all, and you want some other syntax for that. So yeah, I guess that's not a very good answer, but I don't actually know how to quantify the costs very well.
Right. I do like that you're considering what an optimal Nix expression would look like. So the next question we have is from David AK, and it is about why was TOML chosen. Do you think you can answer that?
Yeah. So I mean, I'm not very married to TOML, but it exists. It's well known. So yeah, a lot of tools have support for it. Editors have support for it, and I mean, you could go for JSON. That would be the simplest choice, but JSON is maybe a little bit too primitive because you can't even have things like comments in it, at least not in a nice way. But yeah, so JSON, TOML, YAML, those would be possibilities. And then YAML, I mean, YAML is maybe a bit too complex, but yeah, so TOML is kind of has a it's not too bare bones, so it seems like a fairly decent choice.
Okay. Yeah, I think it's a fairly decent choice as well, actually. I think out of those 3 options you mentioned, you picked the best one, but that's just my opinion. So another question from Andy, and it's, I hope this is an okay question to ask. You can tell me if it isn't, but will I also need a Nix integration test at some point? I wonder what's wrong with just Nix build, the attribute flag, and then doc.
Okay. So that actually works. You can. Sorry, does it work? No. So so ideally at some point it would just work. So you would just have a .doc option that generates the option or the documentation for your module. But well, no, actually that would be quite hard to do. No, so Yeah, so the nixdoc command internally actually it actually just builds a nix expression that takes the flake as an argument. So there's actually not a lot mysterious going on there. So you could actually do it with a nix build and probably with an argument, but I mean that's not very user friendly. I mean then you have to again we want to avoid magic incantations. So just saying nix build or nix doc is a lot easier than figuring out the correct nix build attribute name and so on. I hope that answers the question.
Yep, I think that does. Let me see if there's any more questions. I actually do not think there's any more questions, and I believe that ends the Q&A portion. So yeah, we are on time for that. So I guess this concludes your talk today. So thank you so much. I would like just to mention something just briefly before we sign off. I really do like your avatar on GitHub as Dexter. Is that some sort of inside sort of thing? Like, because I do notice that Dexter is sort of like a precocious, like little like genius that has like a laboratory in his room, and he's always working on experiments. I've noticed for the past NixCon that you've also just like talked about your experiments, so you're both sort of like scientists in your own right.
Yeah, I mean, it's not really any deep thought that went into that, but I was a Dexter fan back in the 90s, and we both wear glasses, so I guess that's close enough.
Okay, I guess that signs off for today. Thank you so
Right,
much. So
thank you so much.
everyone in the chat, please put clapping emojis or loud clapping sounds, and we're live and direct. Can you also like I don't know, you talk about binaries. Put ones in the chat, like go crazy. Come on, I want to see the chat go crazy. Come on. Okay, with that out of the way, I think I have to transition into a different room, so it may be a disjointed disconnection again. Sorry about that. Okay, everyone, I have to apologize here. It seems that our second speaker, Israel, either had some sort of scheduling issue because they are not here. So I am very sorry about that. We will get back to you really shortly on how we're going to adjust around that. And I also add, because I did forget something on Ilko's closing statements, is that there are breakout rooms, like I mentioned at the beginning. In the breakout room that Ilko is going to be directed in, since we're sort of holding them hostage, is Nix dash modules. Yeah, and if you join that, you can continue discussion with him one-on-one, and that is not going to be part of the stream. So yeah, we will get back to you. I am greatly sorry. Okay, everyone, we just decided to push the schedule forward to the third talk. I am sorry about that. So with that out of the way, our next speaker is Gabriel Volp, and this talk is called Nix at Chat Roulette V2. So this talk is going to interest people who would like to make their job and the lives of people at the workplace better using Nix. And they'd also like to convince their employer and colleagues that using Nix is a good idea. So Gabriel is going to be going through their experience on how they did exactly this, working at Chat Roulette. And just some factoids about Gabriel is that they are a really highly active contributor to open source. Their GitHub handle is at gvolp with a total of 2.4K commits. And they're an author of a book, actually. They're the author of Practical FP in Scala, a hands-on approach. And as you've probably already told, Gabriel is a software engineer and is employed at Chat Roulette currently. Okay, you can take it away, Gabriel.
Cool. Thank you very much for the nice introduction. And yeah, it is a pity that you cannot see my face, but yeah, I think that it's probably better for you. So the talk today, it's going to be about two major topics. The first one is going to be about how we introduce Nix at work and what were the necessities that we had and how we currently use it. And the second part of the talk would be more focused on the Scala ecosystem, which is Scala, for those who don't know, is a JVM language. It's kind of like a hybrid functional programming language. So two major topics for this talk. Probably all the experienced Nixers are not going to learn too much from this. The targeted audience for this talk, it's mainly every company out there writing software or making software, actually. So ideally, they will be using Nix, or I can actually persuade them to give it a chance and see how it can help. So a little bit about myself, even though I was already introduced pretty much very well, I currently work at Chat Roulette. We mainly write Scala, but I consider myself a functional programmer. I wrote this book called Practical FP in Scala, and I love Nix. That's why I'm here talking to you today. My Twitter handle and GitHub handle are going to be there in the slides for the rest of the talk. So feel free to ping me there. And I'm also on the Discord chat for the rest of the conference. So how we introduce it at work and how we currently use it. It all started because we had some kind of messy situation. I joined the company early this year, and it starts with a basic need. Basically, we have a mono repository with the whole project that it makes Chat Roulette live. And the backend, as I mentioned before, it's mainly written in Scala, which is a JVM language, and we use Docker and Docker Compose to run a few dependencies like Postgres and Apache Pulsar, which is at the core of what we do. We had TypeScript mainly in the front end, which I guess it runs with Node.js on NPM. I'm not very familiar with that part. I only use it sometimes. And the whole infrastructure tools and software that we run mainly on Kubernetes, on a Istio service mesh and so on. And we have a bunch of people writing code using different platforms, mainly Linux and Mac OS, luckily not Windows. And yeah, so first day I joined the company and I spent it all day on different meetings and talks because I joined remotely and trying to figure out what was all the software needed to actually run the project and all the dependencies needed for the front end, for the back end. And there's also a mix of software needed whenever you need to run the cluster as it runs in production, like if you need Kubernetes and the service mesh and all that stuff. There is a lot of stuff to take in, and I think this was also my experience in previous companies not using Nix, that pretty much everybody expects you to to figure out all the software that you need to run the project locally and to be productive. So that's what I found at the beginning, and the idea was, okay, this is a very good use for Nix. At least let's manage the dependencies that we need to run the project locally, both for the backend and the front end, and whenever we need it for infrastructure, and let's see how it goes from there. So I introduced the first shell.nix with a bunch of dependencies that we needed, and make it work for both Darwin and Linux. And like nowadays, we have something like this. This is just a minimal example. It is a little bit much bigger what we have. We have a few other modules. We have some custom derivations that we had to build specifically for our needs. But the advantage was like very clear to everybody in the team. So in order to introduce it, I only gave a small talk, share my screen, and show people what is Nix and how it works and what are its benefits. And so everybody was pretty much sold out on using Nix. I think it's easier when you introduce it to a group of functional programmers who actually value immutability and reproducibility. But still, everybody was new to Nix, and it's still accepted as part of the, just give it a try. So this is what we have nowadays, and this is it has been very good for the rest of the team and for everyone, specifically because a new developer joining the team only needs to do a few things on day one. The only requirements are you need to have Git installed, Nix, and Docker, because Docker needs to run as a daemon with some other permissions, so we cannot provide it in our Nix shell. But other than that, this is all they need to do. Like on the first box, basically git clone the project, enter a Nix shell, and we have a shell script which actually it starts the whole project if you want to run it locally. So that's all they need to do, and we actually encourage our team to use DRenv. So for those who don't know DRenv, it basically enter a directory, and all the dependencies declared in your shell Nix will be automatically available for you if you run these commands in the second box. So we leave this optional in the company. We don't force anyone to use DRenv because it takes another few extra steps to set it up at first. But we encourage pretty much everyone to use it because it's like you don't need to remember to run Nix shell to then run the other commands. And sometimes where is the build tool commands is not available to me, and it's like, oh, did you run Nix shell or not? So we avoid kind of like remembering whether a user is within a Nix shell or not. So the benefits have been huge. Like now we have reproducible development environments for both Mac users and Linux users, and everybody runs the same version, the same exact version of the dependencies. There is very, very little maintenance. We update dependencies from time to time whenever the need arises. But everybody learned how to update dependencies, how to update the hash of the Nix packages version, because we have the Nix packages pinned to exact version. And like, yeah, even people got familiar with with the SHA-256, the hash, that whenever we update some custom derivations, they also need to update the hash, and that's pretty much what everybody does. So for very little investment, the outcomes and the benefits have been huge for us. And so I would definitely recommend development shells. I think it's the killer feature of Nix. You can do a lot of things with Nix, but I think this is the best seller feature for Nix. And I think everybody out there could be leveraging this. So definitely recommend it. Another use case we have, it's since we compile our microservices using, they are all written in Scala, so the output is the shard that it needs to be run by Java. So it has a Java dependency, and we generate the Docker images using the base Docker images to build upon. Using Nix as well. Here on the left, you can find this is the Docker Nix file. It's very small, but what we have, it is a guarantee that the Java version we declare in our Nix file, it's the same one that runs in production. And I mentioned this because I've been writing code on the JVM for about 10 years, and it is a very common problem, and it happens a few times that many developers, they just run different Java versions, whatever it comes installed with their system. And even if it's the same major version, you could have some issues with different minor versions. And it happened to me a couple times in the past when a different version was running in production, and we had some runtime issues. That's because we compile it with one version, but then it runs with a different version, even if it's only a change in the minor version. So with guaranteeing that the Java version you use to compile it and write code locally, we can guarantee that that's the same exact version that runs in production by creating this Docker image using Nix. So this is another benefit, so there's no more discrepancies with the Java versions that run in production in your local machine. We have a few other projects that also require some extra packages. For example, Tesseract, which is a C++ library for doing OCR. So that's why we have this extra flag, but that's pretty much what we use it. Since we also have the shell.nix with all the dependencies also for deployment, we actually use that in our CI build, like mainly just running Nix shell and a command. We use GitLab runners. Our repository is hosted on GitLab. This is all we have in our production code at the moment. But taking in consideration that it started only a few months ago, I think we made very good progress, and we're still delivering business features that are always the ones with the most priority. So that's the first part, and I think I want to encourage everyone out there not using Nix yet to give it a try, at least for development shells. I think that is a killer feature, that you have reproducible development environments, and you can actually hire new people, and newcomers will be creating pull requests on day one without actually wasting time on figuring out what kind of dependencies they need in order to run your project. I think that is already a killer feature. We also have a few open source projects that we maintain. They are hosted on GitHub instead. I mentioned before that we use Apache Pulsar. It's a distributed message broker, and we maintain two libraries, one for Scala, one for Haskell, and we use Nix also in both projects. But today I'm going to be focusing on Neutron, which is the Scala version, the Scala client, because I want to continue talking about the Scala community and Nix. So whenever people start using Scala and whenever people start trying to use Nix in a Scala project, they will do something like this. For example, like pinning the Nix packages to a specific version. It's just creating a shell with the Java development kit, specific version, the JDK 11 in this case, and SBT, which is the Scala build tool. It's one of the standard. Yeah, it's the most standard build tool in Scala, and yeah, so that's how people might start, and actually how I started when I was learning Nix, and then we run SBT, and we get a message like this, and say, hold on, why is it Java 1.8 in there when I actually want the JDK 11? So this always comes as a surprise for everyone. I know it was a surprise to me as well, but it actually makes sense if you think about it. SBT gets packaged in Nix packages, and it needs to be packaged with all its dependencies. And SBT depends on the Java version. So in order to build a reproducible SBT binary, we need to know what is the version of Java. So there is a default version in Nix packages. In this case, it's Java 1.8. But overriding the default version is very easy. You do something like this, basically SBT override with a specific Java version. So we have something like this at the moment. Basically, we parameterize over the Java version, and we override the SBT version, and then we have a shell.nix, which has also an argument for the Java version, and we have a default argument. It defaults to JDK11, but it could be overridden if we just pass it as an argument. So next time user run SBT, then we are welcome with SBT with a specific Java version that we want to run, and that's it, right? So that's one thing. We also use Nix in this project on GitHub Actions. The benefits are, again, that we can use the same Java version we use for local development in the CI build, and we can actually parameterize. Since we have parameterized our shell Nix by taking a Java version, we can compile and run the test for our project with multiple Java versions. So this on GitHub Actions will run three different jobs in parallel for the different Java versions here. In this case, 8, 11, and 14. And if you pay attention to the last command, which is a Nix shell at the end, it actually invokes nix/ci.nix. That is basically the same as shell.nix, except it only has SBT as a dependency because we don't need more in the CI. And when it runs 3 parallel jobs like this. Well, we run Apache Pulsar using Docker Compose, which is exactly what we do locally as well. And then the rest runs using Nix. So I think this one is a very cool use case. Unfortunately, we cannot use it at work because we use GitLab and GitLab runners. But I really love GitHub Actions as well. So we use it for our open source projects. We use Cachex as well. You might have seen it there in the GitHub Actions declaration. And the thing is, like, we override the version of Java for SBT for multiple Java versions. So, and if you have a file like this, an sbt.nix that we have, if we override it with 3 different Java versions, then this will create 3 different SBT binaries that they are different hashes. And we can actually cache these binaries to pull them from the binary cache on the CI build, as well as on different machines, so developers don't have to build it again. And thanks to Domen for creating Cachex, actually free for open source projects, so it's awesome. So that's what we do, and don't have to build SBT, and improves the CI build times. So that's pretty much showing a little bit of the Neutron project that we run. But I want to talk a little bit about how Nix is perceived in the Scala ecosystem, and how many users are using Nix, and yeah, what is the current status? Because JVM languages in general, they don't get along very well with Nix, and there's a reason why. I guess the JVM ecosystem is huge. There's another talk by the end of the day by Farid about the Java and Nix, which I'm looking forward to hear. But recently I ran this Twitter poll, just focusing on the Scala community and asking the users, the Scala people, whether they use Nix in their Scala projects, and the results speak for themselves, right? There's more than 300 votes. Most of the people don't use it, and a high number of people don't actually know what Nix is. So yeah, the results are a little bit sad, but I actually want to change this, and I'm trying to create more awareness of Nix in the Scala community, which is where I believe I have a bigger voice. And there were a few attempts to Nixify Scala projects using SBT. And these two projects, SBT to Nix and SBTix, which are really ambitious. They try to create kind of like a file lock with all the dependencies, but it's actually very complicated. SBT is actually very complicated. The whole JVM, it's complicated, and Scala makes it even more complicated. So unfortunately, both projects seem to be abandoned today. And actually, I gave them a try a while ago, and it's hard to get them working. They seem to work on small projects, but whenever you have a complicated setup, which is most of the time the case for Scala projects, then they fail to build, and it's they are not being actively.
Hi, Gabriel. Just one moment.
Yep.
I just want to mention that you are actually in your Q&A time, just so you can know that. Sorry.
Oh, it's just like the talk ended. Sorry.
It's okay. Since we have extra time, we can allocate an extra 5 minutes to that, if it's okay with you.
Yeah, like I actually didn't get any notification for that. Oh, I'm sorry. I wasn't following the chat. Oh, okay, yeah, I saw it now.
Okay, proceed.
Do you have 2 more minutes to finish the talk then? No, sorry.
So you basically the 5 minutes you can take for now, since we have an extra 5 minutes to the Q&A because of the other talk got canceled.
Oh, okay, sorry, I didn't see the message. I wish I could finish.
So you have 5 minutes now.
I was nearly at the end. All right.
You can continue your talk, actually. I hope you understood that. You can actually continue. We have extra 5 minutes.
Okay, I'm sorry. Yep, so, okay, trying to finish it quickly. There is another project that I came across recently by Francesco Zanini. It's called SBT derivation. And it is not so ambitious. It only creates a dependency, a hash, like 2 derivations, one for the whole tree of dependencies and another derivation for the project itself. And it seems to work pretty nicely. There are a few areas where it could be improved, like actually leveraging cache and stuff, but it actually works, and it's actively maintained at the moment. And because of this, the Twitter results, the Twitter poll results, I wanted to create more awareness of Nix in the Scala community. So I started creating this guide, which is also a SHE-8 template. SHE-8 templates are the common way to create new Scala projects. And it basically tells a little bit about Nix and how it could be useful for Scala projects. All the users, all they need to do is basically run this command, and they will have a project with with an opinionated Nix setup, so they can actually build the project using SBT derivation as well as creating Docker images. And they have all the setup for running on GitHub Actions using Nix and Cachex as well. So I'm out of time, but you can try this out at home if you're interested. And yeah, thank you all for listening, and I'll be taking any questions.
Yeah, you have one question that I can give to you right now, if that's okay?
Yep.
Okay, so from Lambda Duck on IRC, it says, how do you build Docker images from Mac machines, if you do?
From Mac machines, from Darwin, I mean.
I believe that's what the question is about.
Mac OS. Well, I don't know. I never used Mac in my life, and I will never do.
Oh, okay.
But yeah, we used Linux, and we build the Docker images in the CI build. But I think it should work on Mac OS too. But I don't know. I will need to check with my colleagues to see how they do it. But I guess they just run Nix build as well as the same way I do it.
Right. Okay, I don't see any more questions. Wait.
Okay, then I'll stop sharing the screen.
I think we might have one more question. So what was the most surprising part of introducing Nix into your infrastructure? I think we have time for one more question. At work.
I'm sorry, your audio just went away. Could you repeat the question?
Yeah, okay. So what was the most surprising part of introducing Nix at work? If you can answer that question.
The most surprising part of introducing Nix. So now I'd say, well, I don't know if surprising. It wasn't really surprising to me because I was already using Nix for my open source projects.
Then what surprised your coworkers the most, maybe?
I think like there was no surprise. Like everybody liked it, and I think you only need one person to take the lead on and actually promote the usage. And if everybody is happy with it, then that's it. But yeah, don't think anybody was surprised. I think
Oh my gosh, you're incredibly lucky. Other people have much harder time.
Yeah, I believe so. Yeah. As I said before, like when you introduce something that is functional, which promotes reproducibility and immutability to a group of functional programmers, I don't think there is a huge surprise because we are used to write functional programming and we know the benefits. So I think it actually fits in pretty much.
Right. If it
pretty
were
well.
like to like people who work with Python, it would have been a different situation.
I think that would be a big shock. Or like at least there would be a bigger surprise. But yeah,
It could be like the first functional programming language for some people.
Yeah, exactly. I don't know. Yeah, I don't have
Okay.
experience with other languages that are not functional.
Okay, I think we're out of time. So thank you so much for being available early since our other speaker wasn't able to make it. You really did save us being able to do that. So we had to like cut to a 25-minute break or something.
No worries. Thanks, and sorry for not checking the chat. I was actually really lost. I was just looking at the slides and.
Oh, your slides in your presentation was great. So I think you doing that has helped you focus. It's okay.
Okay, I'll share the slides anyway on Discord and on Twitter. So yeah.
Yep. I will also tell you about the breakout rooms. Is that you might have heard before. We're going to force you into them. So your room key for your breakout room, if there's any like discussion, if there isn't, I guess you can just like leave. Is just chat roulette at this instance.
Oh, okay. No worries. Well, thank you very much for organizing this. I know it's not easy.
Yep, it definitely isn't, but it's very rewarding. Okay, with that out of the way, we have some announcements. So
cool.
from our moderator, we have a change in asking questions. So if you're going to ask a question during the Q&A portion, you need to join NixCon Q&A and to ping N Botham for your question. And I don't think we have any other announcements besides that. So yeah, we're going to be going to a 5-minute break until next talk. We'll see you all then. Okay. Okay, tell me when, so we need to start now.
Excuse me?
That was the puck. Okay, hello everyone, we are back with a new talk. This is talk number 4, Nix Flakes in production, what, why, and how. And our presenter is Alexander Bantiv. I hope I am saying that properly. If I am not, I apologize. So the topic of this talk is Alexander's experience using Nix Flakes in production at the company Sirocco. They've been using Nix there for over 5 years, and they've just started their internal effort to use Flakes in build infrastructure and projects. This talk is going to have a refresher on what Flakes are also. So if you've been confused by them, here's your chance to learn and have explained why Flakes are so promising, and just sharing general experiences and advice on the matter. Oh, and I did forget the announcement. I forgot to say thank you properly in the chat to Gabriel last talk, and also you don't have to put ones if you are non-binary. You can put hexadecimals because the binary doesn't apply to you. Anyways, go ahead.
Hi, I'm Alexander, and I write Nix at Sirocco. Once again, because of some GT issues, you won't be able to see my face, but that's probably for the better. Lately we have started switching to Flakes, switching our production system pipelines to Flakes, and I would like to explain why we do that and how we do that. So you can find sources for this talk at this URL. It will go public after I finish the talk. I encourage you to build this and follow it along by yourself. So for a quick reminder, what are those Flakes again? Well, Flakes were proposed by Ilko Dolstra in RFC 49. The RFC is currently withdrawn, but nevertheless, the work on Flakes is ongoing in Nix master branch, and hopefully the RFC will be resubmitted soon. Okay, but what are they? A flake is basically a directory that contains a flake.nix file at the root. That's it. The repository that the stock is built from is a flake. Nix packages is a flake. Nix itself is a flake. Flakes also tend to contain a flake.logs file in them. So, for example, yeah, this presentation is a flake. What's in those files? Flake.nix file is a simple Nix file that contains an attribute set. The notable attributes are description, inputs, and outputs. I'll explain what those means later in the talk. Flake.log is a JSON file that pins all the versions of the inputs. Now that you have hopefully been reminded about what flakes are, and you hopefully understand about at least something about them, I would like to explain why we use them in production. First, let's take a look at what we need from our production build systems. First of all, we need our production build systems to be reproducible. That means that two people building the same project should get approximately the same results. We need our build system to be easy to use, which means that people who have little experience with Nix should be able to easily at least build the project and run it. And we need our build system to be cross-platform because our developers use all 3 major OSs and we need to support all of them. So to understand why we are so excited about Flakes, let's take a look at the alternatives. We'll use a simplified version of the stock's Nix expression as an example. First alternative is channels. Channels are a very simple idea. You have a separate command called Nix channel. It downloads and unpacks tarballs somewhere in your Nix path. The benefits are quite obvious. You have a very easy way to write standalone Nix expressions using angle bracket syntax. So import Nix packages. This will give you well, the Nix packages dependency. It's very easy to update dependencies using Nix channel update, and it's very easy to override dependencies by changing Nix path environment variable. The drawbacks are quite obvious as well. Nix channel is stateful because every user has to run Nix channel add before they can build your project. Channels are not composable because channels can depend on other channels, and the channels are not reproducible at all. Because unless you jump through some hoops, your users will get different versions of dependencies than you. Second alternative is pinning with fetch tarball. The idea is quite simple as well. You use the built-in fetch tarball function that Nix and Nix will fetch that tarball that you specify in URL at evaluation time, and then you can use it as usual, for example, with imports. The benefits are that this is somewhat reproducible because you have to specify you can specify the git revision and the hash of the tarball. It's somewhat composable because your dependencies can use the same mechanism to fetch their dependencies, and it's stateless. Your users don't have to run any comments other than Nix build. The drawbacks are that it's quite cumbersome. You have to manually get the commit versions, you have to manually get the hashes, and to update them, you need to manually edit the default.nix file or wherever you have those arguments, wherever you have specified those arguments. A third alternative is NIF. NIF was created by Enmatia, and it promises easy dependency management for Nix projects. And it does deliver on that promise. We have switched most of our projects to use NIF before we started experimenting with Flakes, and that wasn't any time wasted because transitioning from NIF to Flakes is easier than transitioning from channels to Flakes. The benefits are that it's once again reproducible, composable, it's stateless. However, unlike fetch tarball, it's also very easy to update dependencies using the NIF command, and it's easy to override dependencies. The only drawback is that it requires a separate tool, which doesn't integrate into other Nix commands too well. Actually, all of those approaches have a set of common drawbacks. First of all, lack of standard structure. There is no standard format for default.nix, meaning that every project implements their own. I have seen a default.nix with a single derivation, another set of derivations, a list of derivations, and so on. And so it's not very easy to use because your users have to guess which format your project uses. Second drawback is extreme reliance on Nix packages. Many of the old sort of Nix commands somehow implicitly rely on Nix packages, for example, Nix shell. This is bad for projects that simply can't be added to Nix packages or that don't use Nix packages, or the projects that want to use a custom Nix packages version. There is no simple way to enforce hermetic evaluation because both fetch tarball and NIF are somewhat reproducible, but they don't enforce reproducibility. You can still import from impure locations, use angle bracket syntax, etc. And finally, there is no integration with the rest of Nix because there is no easy way to, for example, overwrite inputs from Nix command directly. This is, again, not very easy to use. Well, as you might have guessed, Flakes solve all of these problems. They impose a standard structure on flake.nix, remove any reliance on Nix packages and tooling, at least mostly, enforce hermetic evaluation by removing Nix path and built-in current system, among other things, and integrate tightly with other Nix tooling. Let's take a look at an example of a simple flake. There's quite a lot happening in this file, and we'll get back to what everything means exactly later in the talk. For now, note that we specify inputs by describing their locations, but not their versions. So here we describe the location from which we want to fetch Nix packages. And that outputs depend on inputs. So here outputs depends on the input Nix packages. Also note that we never use built-in current system, and instead we map over all of the platforms exported by Nix packages. I'll explain how to do this a bit later as well. Updating and overriding is very easy using the update input and override input command line flags that almost all Nix commands accept now. With Flakes comes a new Nix command line interface. It is also, in my opinion, it is more concise and it is definitely more uniform. Now all of the Nix commands accept the same format of arguments, a Flake reference, and they also share a lot of common flags, unlike the old interface. Old interface is still kept for compatibility. Flakes also introduce Flake references. Flake references are dramatically simplify fetching remote projects. So, for example, instead of writing this monstrosity, we can now just tell Nix this simple location, and it will do what you would expect. It will fetch this repository from this host and open a shell with the default package of it. So to reiterate, Flakes solve many problems that we were facing with Nix, which is why we have decided to use them for many of our projects. Now that you are hopefully about as excited about flakes as we are, I would like to explain how you can use them in your current projects and integrate them into your current infrastructure. First of all, in order to manage flakes, you will have to use a recent enough Nix. The easiest way to get such a version of Nix is to use Nix shell p unstable, p Nix unstable, which will fetch a pre-built Nix version, so you don't actually have to build anything. I also encourage you to read Ilko's blog posts on the matter. He explains in a lot more detail the decisions that were put into flakes and some other things, and they are a great read. There is quite a lot of information about flakes on the web, but I haven't found much advice on how to actually write or integrate flakes into already existing projects. I would like to remedy that by explaining what everything means in a flake and sharing my experiences of flakifying our infrastructure. Let's start by initializing our first flake. To do that, we will create a new directory and run nixflake init in it. Nixflake init is a command that places a skeleton flake.nix file in current directory, so it doesn't do anything fancy. Then we create a new Git repository and add everything to index. I'll explain why that is important in a bit. Let's take a look at the skeleton file that Nix placed in our new directory. Description is pretty obvious. It's just a string describing the current flake. Outputs is a function which returns as an attribute set of well outputs. There are some standard outputs. For example, both packages and default package are standard, but you may also provide your own. Argument of outputs is an attribute set of inputs. Self is always an input, and it refers to this very flake that Nix is currently evaluating. Nix packages here is an indirect input, meaning its value is taken from a flake registry and not from inputs attribute of this flake. Don't worry about it too much for now. As you can see, all of the flake outputs, for example, legacy packages is an output of Nix packages, are available as top-level attributes of those inputs. So Nix packages.legacy packages is an output of Nix packages. You can also access other flake attributes such as description or inputs. And also some flakes provide some information about their source. If you cast any flake input to a string, it will return the path to that flake's source from which it was evaluated. Now let's take a closer look at this line of outputs. Packages is an output which is an attribute set where attribute names are systems and attribute values are attribute sets in on themselves, but where attribute sets of derivations. So let me say that again. Packages is an attribute set where attribute names are platforms or systems, and attribute values are attribute sets of derivations. Legacy packages is an output designed specifically for Nix packages. It's an attribute set of, once again, where attribute names are platforms or system, but attribute values are arbitrary attribute sets. This allows us to stuff the entire Nix packages into this output. Default package is an output which is an attribute set of derivations, and names are, once again, systems or platforms. Here we set the default package for x86-64 Linux to the output we have defined one line earlier. So self.packages.x86-64linux.hello is, well, it's exactly this. Nix doesn't do any fancy not tying here. Now that we hopefully understand what everything means in a flake.nix file, it's time to use it. First of all, let's build the default package for the current platform. To do that, we can just run nix build. The first time we run nix build, Nix will fetch all of the dependencies that we have specified in inputs and pin their versions in flake.log file. It also warns us that the Git tree is dirty, meaning that other people won't be able to easily reproduce our results. We can also specify the default package for the current platform explicitly using flake references. So dot is the URL, then hash, and then we can specify any output we like. If we run the result in binary, it outputs hello world as expected. We can also use Nix shell to to get ourselves a shell with the binary in path. It once again, when called without arguments, it will drop us in a shell with default package for current platform, but we can also run it with any arguments. And now we can just run hello because the binary is in path. Now let's examine our flake. Now let's examine our flake. We can use Nix flake list inputs command to tell Nix to list all of the inputs of our flake. In our case, this is just our flake has just one input. It's Nix packages, and as you can see, Nix tells us exactly the version, the Git revision of Nix packages we're using. You can also run Nix flake show, which will show all of the outputs of the current flake. So here our flake has two outputs: default package and packages. Now let's improve our flake by providing outputs for all systems instead of just x86 64 Linux. As you can remember, we have specified x86 64 Linux here explicitly, which means that currently our flake doesn't provide outputs for other systems. To do that, we will use built-in map patterns function to map over all of the available systems in Nix packages legacy packages. For every such system, we will return an attribute set where hello will be equal to hello from that package set for that particular system. Default package is very similar. We once again use map patterns function, but this time we map over the packages output of this flake, and for every per platform package set, which for every per platform package set, we choose hello from that package set, which we have defined here. So this means that default package for every platform is equal to hello output for every hello package for that particular platform. Now let's try building our flake, our package for another platform. To do that, we will run a Nix build command, but this time we will explicitly specify that we want to build hello package for x86 64 Darwin. And quite surprisingly, it builds. That's because Hydra actually pre-builds a lot of packages for Darwin, and they are available for download on cache.nixos.org. So Nix just substitutes that binary instead of building it. But obviously, if we try to run it, we get an exec format error that signifies that we're trying to run a binary for a different platform. So it works. Now let's add a runnable application. Applications are a feature introduced by Flakes. They are implemented with apps and default app outputs, which are similar to packages and default package correspondingly. Both of them are, once again, similar to packages and default package, but instead of derivations, they have attribute sets of form type equals app and program equals to the executable you want to run. So here we define default app by mapping over all of the platforms or, well, packages exported by default package. And for every platform, we run the executable for the platform as a program. To run Flake applications, you use the NixRun command. And if we do this here, it just outputs hello world, just as we would expect. Now let's add a test. Here I will add an inline bash test, but obviously you should use the test suite provided by your actual language. Here I will map over all of the package set in legacy packages, and for every platform, I will use run command function to run some bash, and in that bash we basically just execute the hello package from this current Flake for the system that we're currently checking for, and compare the output to hello world, which we expect. To check, we need to run Nix Flake check, but if we run it without any flags, we won't see any output because by default Nix hides all of the output. If we run it with an L flag, it will show us the successful output. So it tells us that hello output is hello world, and it expected hello world, which matches. Now let's break it and try to check. So we just replace the expected output with an incorrect one and run Nix Flake check again, and now it fails just as we would hope. Now let's package a local application instead of re-exporting one from Nix packages. I'll package a simple Haskell application. I won't go over into what happens on the Haskell side. It's pretty simple. It just prints hello world. Okay, yeah, for some reason I'm talking quite slowly now. I guess I'll skip the unimportant parts. So this is a very simple call packageable expression. It just takes two arguments, stdenv and GHC, and it uses MK derivation to quite simply build the package using GHC with no fancy cabal or anything. So it should be quite easy to understand. Changes to Flake.nix are very trivial as well. We just replace packages.hello with packages.callPackage, hello.nix, and no overrides. And if we try to build it, it doesn't work for some reason. Why is that? Well, remember I told you that it's important to add everything to Git index. That's why. Because before evaluating a Flake, Nix copies its content to Nix store, and it also removes everything that's not in Git index. So if we add everything to Git index and then try building again, now it works. And if we try to run in our application, it outputs hello world just we have expected. And Nix run also works. Nix Flake check will break because GHC is not available for some platforms and for some complicated reasons, which I won't go into here. So Nix Flake check will fail now. Let's now add an overlay, because providing a buildable derivation is nice, but providing an overlay that can be used with any Nix packages version is even nicer. Overlays is an output which is an attribute set of overlays, and overlay is an output which is just one overlay. Overlays are functions of two arguments, final and previous. Please note that here in Flakes, Nix actually enforces that the arguments are called final and previous. And here we just overlay a very simple override with set hello in the particular package set to the hello.nix to call packaged hello.nix from the current directory. Let's also ship a NixOS module with our application. This is a very simple NixOS module. It just provides two options and a systemd one-shot service, which just runs our hello application. Importing it into Flake.nix is pretty trivial as well. NixOS modules is an output which is an attribute set of, well, NixOS modules. And here we set the hello NixOS module of this Flake to module.nix. Now let's add a, sorry, what was that? Oh yeah, I'm sorry. Now let's add a version flag. I won't go into changes in the Haskell side again, but note that it takes an environmental variable called version at build time and uses that as a version output. Changes to Nix to Nix build-in side are very trivial too. We just pass it a version environment variable here. Changes to Flake.nix are a bit more interesting. Here we use the fact that Flake inputs actually provide more attributes than just outputs. For example, all Git flakes provide revision attribute when they are not dirty and last modified date when they are dirty. So here we provide so here we set the version to be hello, and then either the revision or last modified date of this flake and Nix packages, and with either the revision or last modified date of Nix packages. And obviously, and obviously now if we try it, it actually works first time. It tells us that hello was last modified on October the 7th, 2020, and that Nix packages is this revision. It tells us the date here because remember that we haven't committed anything to Git yet. Let's do that, by the way. Now we commit everything to Git and push our current repository to somewhere, to some hosting. This basically meant that we have just published our first flake. We can now use flake references to just as we to do everything we have done locally, but now remotely. So, for example, if we want to run the application that we have exported, we can just use Nix run and then pass it the flake reference to which we have pushed our flake. If you don't want to publish your repo, you can just try Nix run github balsoft hello flake. It contains all of the files that I have discussed earlier. But wait, you might say, unstable Nix is not an option for CI developers. That's true, but worry not, Ilko has a solution for you. It's called flake compat. You can put this very simple Nix expression in default.nix file. It actually just fetches the latest version of flake compat and then calls it with the src argument of the current flake. This has the result that now we can use old Nix versions, so for example 2.3.7, to build our flake. Some features like flake applications won't be available and you can't manage the inputs, but that's at least something you can easily tell your users or CI to do. Now let's deploy our application. This is a fairly common situation for software companies where you are developing an open source project and you want to deploy it to your servers. Obviously, including server definitions in the project would be a bad idea because other people may have their own deployments and they obviously will have their own server definitions. So let's create a new project or repository with infrastructure for our flake. We just initialize a new Git repository. We won't do Nix flake init this time because we will write our own Nix flake from scratch. And let's go over what I have written here. Description is once again a very simple description of the current flake. Inputs, we haven't encountered this before, so I'll go over what happens here. Inputs.hello.url is a URL from which Nix will fetch the flake. Here I just set it to the URL to which we have published our flake earlier. This line, inputs.hello.inputs.nixpackages.follows, tells Nix to substitute whatever version hello flake, whatever version of nixpackages hello flake has in its log file with the nixpackages version that this infrastructure flake is using. This allows us to reduce the amount of nixpackages version we depend on, but at the same time it removes some of the reproducibility. You can also specify flake equals true, but this is the default. If you specified flake equals false here, Nix wouldn't interpret the hello flake as a flake, and it will just give you the path to the source. This is useful for dependent on projects that aren't flakes yet. Now let's write our server definition. We'll start with a simple shim because we will be running our server in a NixOS container, and NixOS containers don't need any bootloaders or file systems. So here, I just set both of those to dummy values so that NixOS evaluation succeeds. Now let's look at our flake.nix. Here we use a NixOS configurations output, which is obviously an attribute set of NixOS configurations. We set the hello NixOS configuration to the output of nixpackages lib NixOS system, which is a function that builds a NixOS configuration from some modules. We tell that NixOS system that we will be building an x86-64 Linux NixOS system, and we also pass it a list of modules. Modules has the same semantics as inputs in your configuration.nix file. Here we will pass it 3 modules. First of all, the NixOS modules hello, which we have defined in our hello flake. We also pass it the shim.nix, which we have defined earlier. And we also pass it an attribute set, which contains an overlay from our hello flake, and it also enables the service from which we have defined in our NixOS module in the hello flake. Now let's try it in a NixOS container. To do that, you will need a recent enough version of NixOS container that understands flakes. You can get that with using Nix shell, nixpackages --NixOS container. You can then use sudo NixOS container create and pass it a flake argument. This is a flake reference, so current directory and output of hello. This will actually resolve to NixOS configurations.hello. And we name our container hello. If you want to update the configuration, you just replace create with update here. Now you can start the container. For reasons unrelated to flakes, it will hang during boot, but you can just ignore that. Just kill it after 5 to 10 seconds, and you can move on. You can then run sudo NixOS container root login hello to get a root shell inside the container. Inside the container, you can restart the service to make sure that it actually outputs something, and then look at the logs for this service using journal control. And as you can see, here it actually does output hello world to the standard output, which is great. It means that our deployment is working perfectly. Obviously, NixOS containers aren't production ready, so you want to deploy to either real hardware or virtual machines. There are plenty of tools that allow you to do that. For example, NixOS rebuild is now Flake aware, so you can pass it the Flake argument just as you can to NixOS container. Also at Serakel, we have been developing our own deploy system, which is just called deploy, quite unimaginatively, and it uses a the deploy output of a Flake to determine where and what it needs to deploy. You can read more about it here. And you can also use pretty much any deployment tool you have been using previously by just building the NixOS configuration manually and then passing that pre-built NixOS configuration to your deploy tool. While I have been experimenting with Flakes, I have read some of Nix's source, and so I have found some features which are rather poorly documented or not documented at all or are otherwise not obvious, at least to me. If you want to override dependency of a dependency, you can use slash. So, for example, to override the hello, oops, this is a mistake. If you want to override the hello dependency of this hello info flake, you can pass Nix flag of override inputs hello / Nix packages and then pass it some flake reference. So, for example, this is a local Nix packages checkout. If you want to update all dependencies of some flake to latest versions, you can use a create log file. Actually, all Nix commands except this. This will just delete the old log file, download everything from scratch, and create a new log file. If you want to forcefully refetch the latest version of a flake, for example, if you're using Nix shell, Nix will cache that. If you're using Nix shell with a remote flake reference, Nix will actually cache it. And so if you want to make sure you're using the latest version and not the cached one, you can run Nix flake update, then the flake reference, and Nix will refetch that flake. And finally, if you don't want to write the built-in mapatters thing every time you're writing a flake, you can use the very awesome flake utils, flake by Numtide. And so that about wraps it up. Thank you very much for listening. And if you have any questions, I guess there is no time left, unfortunately, because I was before. And you can ask me questions, I guess, on Matrix or on IRC.
One second here. I think you actually will have time for a Q&A portion. We decided that you can, let me check the chat really quick. Yes, you have time for questions for sure. So we're going to give you the full Q&A.
Wow, that's awesome. Thank you.
Okay, let me forward you the first question if you're ready.
Yeah, I'm ready.
Okay, so we have Farleon said, what's the most challenging part about using flakes right now? And another bullet is, if you could change one thing, what would it be? So I think you can answer the first one, the second one.
Yeah, the first one is that the most challenging part is, I think that as with most things in Nix, the documentation is, well, it's there, but it's not complete. And another problem, I guess, is that flakes are, and the unstable Nix is quite unstable, actually. So before, in August, and in September, I've had quite a lot of issues with Nix, which I had to somehow mitigate myself. But now the documentation actually improved a bit, because there are more and more articles on flakes being published. And also, unstable Nix is a lot more stable now. And actually, all of our team at Serakel are mostly switching to unstable Nix now. So I guess a lot of the challenges are going away. And if I would change one thing, it would be, well, my suggestion, which I'm currently working on, actually, it's that I would create a plugin that allowed built-in fetch tarball and built-in fetch git inside Nix flakes to work without hash or git revision, but so that they would log their versions in log the versions of what they're fetching in flake.log. It's a bit hard to explain, I guess, but I hope to have a PR ready soon. Or, well, maybe not soon. I don't know. It's quite a hard task.
Okay, I have another question, several questions actually, from Rison. The first one is, I have found that substituting inputs isn't recursive. Do you know if that is intended?
Well, actually, I don't know if that's intended, but I think this should actually answer your question. So you can use this slash syntax. You can actually also use it, if you know a bit more about Flakes, you can actually also use it in, oh no, actually disregard.
I see he has a couple other bullets, I think, that I can share. So he extends the question a little bit. So it also says, to extend on my question, let's say I want to use Flake B. Flake B uses Flake C and substitutes its Nix packages. Now I am in Flake A and substituting Flake B's Nix packages as my own. Then lastly, Flake B Nix packages get substituted, but Flake C's Nix packages stay the same as the origin Flake B's Nix packages. I hope you can understand that.
Yeah, I can understand that you can do some clever things with follows to mitigate this. So basically, if you that's a very good question. It's very hard to explain without writing some code, but you can substitute those inputs recursively. Actually, it's possible. We have faced this once, and there is a solution, but it's quite hard to explain.
Okay, you probably can go into the breakout room and maybe Ristin can be there and you can talk about it.
Yeah, that would be, I think, yeah.
So let me see if there's any other questions, and if there's not, then I will just sign off. Okay, I don't think there's any other questions. Thank you so much. We made the last minute decision to extend yours to all the way to have the extra time we have, and I think that was a good use of time, since this talk will probably be really popular for people, since Nix is a hot topic to at least know about, since, as you mentioned, the situation with the documentation. So thank you excellently.
Yeah, okay. Thank you very much.
Yep. And if everyone could please, I will beg you to put those claps, put those ones, put whatever to say thank you, because in person you can't actually, you'll be able to hear the clapping, but here we cannot hear, so just show the love. Okay, so on to announcements. Due to logistical issues, I believe this has changed of the duration our food break is. I'm sorry. I have to see what exactly that time would be. Nick, do you think you could share that with everyone while you're in here? Like for example, maybe like you said localize it. Yeah, maybe something like that. I'm still not really sure, since we had to update that. Do you think you could speak on that? I'm sorry to put you on the spot like this.
That's okay. Can you hear me?
Yeah, I can hear you.
Yep. So Dillman's talk will start at the time that it was originally scheduled for.
Right.
Which is 1500 UTC. So we'll be back on air approximately 2 hours from now at 14:45 UTC. So like for -4, that's 11 a.m.
Okay, great. Thank you. I hope that explains everything to everyone. And if it isn't still clear, we can follow up something into the topic in the channels. Okay, great. See you all then. Thanks for watching. Hello again, everyone. We're back and kicking off the second half of today's conference. So some of the details of logistics have been a little more solidified so everyone can understand them, so I will recap them here. So we have 5 more talks today, and they're 25 minutes. In the last 5 minutes of talk, speakers will have a short QA. But it's possible that speakers could eat into that time, so your mileage may vary if you actually get your question answered during that period. So the main way to participate in a talk would be actually directing a question to a speaker during the Q&A. And you can do this by asking your question in #NixCon-QA on Freenode, and Botham, our moderator, will feed those to me so I can direct to the speaker. And the main NixCon channel is just for general discussion, and it won't be watched for questions to be included inside of a talk. There are also breakout rooms for each talk, and we'll be forcing our speakers to move into those rooms after their talk ends. Those will be announced at the closing of talks and linked by Nimbotham in #NixCon on Freenode, and you can continue to have further discussions with them if it's possible. And lastly, if you experience any technical difficulties, please contact at Nimbotham our mod in a PM, and he will try his best to get back to you. So with that recap out of the way, I would just like to thank all of you again, our viewers, for sticking with us and still tuning in and taking a chance on an online conference. I hope it's going to be a beautiful experience. Also, all the speakers that have been available and doing checks and stuff like that and making sure everything goes smoothly. And obviously, lastly, our sponsors who make it all possible. That would be Equinix Metal, Relational AI, NixBuild.net, Mutable, and Tweag. And Tweag's also provided me a readout to give to you today. So Tweag is a global research and development team for hire, applying innovative computer science technologies to help its clients improve software speed, reliability, and reproducibility. Tweag invests heavily in Nix, employing some of its leading contributors and directly funding new tools and features. In 2020 alone, this has included work on Flakes, Nix Ops 2.0, Poetry to Nix, the software heritage integration, the website redesign, and content address storage. You can follow the Tweag blog and Twitter account to keep up to date with the team's work, or get in touch with them at tweag.io. Yeah, and they've definitely influenced some of my good friends here too. So with that out of the way, we can lead into our next talk, which I believe I need to jump in another room, so that will be a slight disjointed transition. I apologize. Give me 1 second. Okay, so I have here today is Domen Kojar, and he will be presenting his talk, How to Change the Nix Ecosystem to Become Mainstream. So he's really just going to dive first into why this matters for the community, and then we're going to take a look at current roadblocks and possible solutions to them. And I did get this information from one of Domen's friends. And just so you all know, it is rather interesting. But if in an alternate reality, Domen was not able to be a programmer, he would probably be a professional gamer. So think of it like a Twitch streamer. So yeah, take it away, Domen.
Thank you so much.
Yeah,
I
you're
want to
welcome.
mention, first of all, welcome everyone. I'm really grateful that we live in such times that we can do this from our homes. I'm going to switch to the presentation now. And I hope you won't see too much of my CPU fan noise. I want to talk about what we can do to get mainstream. And just before I start with this talk, I just want to say this is merely my opinion based on a lot of, I would say, experience or presence, amongst presence, and it's an invitation for collaboration rather than, I think it should be this way and there's no better way and so on, and also an invitation for discussion. So let's dive in. Just before I dive in, just a few things about my history with Nix. I've kind of put way too much text here, but I started 8 years ago. I was introduced by Florian Friesdorf to Nix. I organized with a bunch of other people from Slovenia 2 sprints. Shortly after that, I had a talk at FOSDEM and PyCon talking about Nix and trying to get more people to pay attention. I was release manager for 4 releases between 2014 and 2016, and then I had my full-time Nix job working for Snap, which was really great. Then later, when that finished, I joined IOHK as a DevOps team lead, and 2 years ago, I announced CacheX, binary cache hosting for open source and businesses, and then I joined with Robert on Hercules CI, and then I parted that project, so now I'm fully focused on CacheX, and this year I announced funding for CacheX, which allows me to work on this full time until it's able to cover my living costs. So very briefly, this was the screen in 2013. We were in a small wooden nice house in the middle of nowhere in Slovenia with fiber optics. We had really great time. You can see Elko at the very left. You can see Rock Garbers on the very right. There's also somewhere in there me and a couple of other people you might recognize from this picture. So Nix was very small back then, and this was, I think, the first or one of the first really social gatherings. So what I wanted to go with this is, why does this even matter? Why should we strive for this? And again, I don't think everyone should feel this way or think this way. This is something it's passion to me, and probably I hope for others as well. And we're a big community, a really big open source projects by world standards. And a lot of us that ended up here is because of passion. But now, I think there is, if we really want to go mainstream, we need to do some things. I wouldn't say differently, but rather additionally. So it took about 17 years to come here, and I don't know how many people. I wish there was a good way to count this. Probably just by looking at all the statistics, you get an impression on GitHub. But I think there is a way that is sustainable, in a way that we don't burn people out, in a way that people get fair compensation, and in a way that Nix gets better. So I'll draw this little feedback loop where we have industry use that hires full-time Nix developers, that leads to improved Nix, but also improved Nix leads to more industry use. And this feedback loop can be positive or negative, right? If we get a lot of people who have to use Nix or are forced into using Nix and they're not happy with that, then this kind of goes the wrong way. And if they are happy, they become so-called fans or people who advocate for Nix, and this feedback loop is positive. Well, the only thing we can really influence here is Nix itself, and then industry can do its role. And the question is, of course, what part of Nix should be fixed? Because it's a huge ecosystem at this point, so there needs to be some focus on what are the things that will really unlock this adoption. And most of you are probably software developers, so you know that some things leads to no change, even though you do the hard work, and some things lead to a huge change. So the question is, which one is which? So just briefly, I forgot to mention about why this is important. I think it's when I look back 8 years ago where we were then and now, I see, this really amazing change of all the tooling that has been built and everything we've done that we never could have done with, those 50 or 100 people back then. So I see this the same way going forward. We can only do as much in our time that we have. So getting more people into the problem, it doesn't solve all the problems. It creates some problems, but it does solve that we get to enjoy better Nix. All right. So the question is how to get mainstream. And I would like just for a minute to ask you, what do you think? And those who are on NixCon channel, you can write there your thoughts. I'm curious if you're on the live stream. I think on the right side you should have IRC. And yeah, I'm curious about your thoughts, and I'm gonna go there and quickly check. What do you think? And then I'll go into what I have to say about this. So let's give it a...
I don't think I saw any questions just yet, gentlemen.
All right. Let's see if people... all right.
Yeah, if you see them in the NixCon channel, we shouldn't exactly take those from they need to be in the NixCon QA channel.
Yeah, I'm just going to read a couple of ideas from people and move on. Because, just to get some fix, the installer website has improvements have been great. Documentation is a big deal. Fix the installer, predictable command line API. All right, I'm going to switch back to my talk, but I'm going to read those later on. And I'm curious what everyone thinks. So I think there's two parts to getting this right. One is to focus on doing one thing well, and the other is to listen to newcomers for feedback. And I think these are both kind of recipes in general for a successful project. But this is the angle at what I'm gonna look at here. So do one thing well. I joke often that, Nix is JavaScript for DevOps. It's funny, it hurts at the same time, but I think there's some truth in there. But better way to say it, it's an API for DevOps. And that's a really huge surface to solve. So I think it's better to go into more specific bits, like, it's a way to set up development environments and so on. We already have kind of a problem here, what that thing is that we do well. But I think those are good angles, saying, okay, we're the API for DevOps, and then we go into different bits, development, build, deployment, and so on. Yeah, and for listen to newcomers for feedback, I gathered a bunch of tweets here because I think they resonate well with, the feedback in general. Of course, I cannot I didn't do any real analysis or a scientific method. This is pure, just my judgment. But here, there's a bunch of tweets. I'll read a bit. While I'm extremely grateful for the effort that's gone into documentation, I don't feel like it's there yet. I spent a lot of time refiguring things out. While it's a brilliant system, there are still sharp edges, missing the application, list of patterns, best practices. Running Nix and NixOS for almost a year. However, documentation is hard. It lacks guidance for beginners. Hard to see how pieces relate. We need advocates to simplify this process. I really want to like Nix. I'm just terrified to try again, and when I see how documentation is essentially unchanged. Steep learning curve, largely due to lacking documentation, poor discoverability. Yeah, there's a bunch of other tweets. I was also frustrated when I started Nix, but it has a learning curve and the documentation is not the best. By far, Nix's biggest problem is not the obscure language, it's the lack of reasonable documentation material supporting a reasonable learning curve, and so on. Here is someone saying that the instructions they copy doesn't work because it wants to build a NixOS attribute which relies on NixOS channel, but if you're on Nix packages, that won't really work, and so on. So here's in the middle, there's how long do you think it would take for an engineer without Nix experience to convert a setup similar to the one posed using Nix, including learning time? We have 15 Haskell services that have considered moving to Nix, but assume the switching costs would be too high. And the last one, I like Nix a lot, but when I use it, I found the documentation sorely lacking. Has the culture progressed past just read the Nix files in the past couple of years? So it's all about developer experience, and if we want to have that feedback loop, we kind of have to acknowledge what are the gaps there, and the feedback is there, it's consistent. So it's not that I want to share some positive light on this. Here is a graph of pull requests per month on the Nix repository. I'll be mostly talking about the Nix repository because I think a lot of these things come from that. That's where all the core is. And you can see a sudden rise in the recent months. I think this is due to two reasons. One is we finally have a really good CI, a story on GitHub for Nix repo, which started in end of February, March. And we have the IPFS effort, which led to a lot of contributions. So things are going in the right direction. All right, so documentation, that has been, I think, number one, and I think it's by far the most important bit. So again, a few positive things that are happening. In the Nix master, we have a documentation command, which will, for now, print a documentation for all the built-ins and so on. There is the Nix manual in the master repo is now written in Markdown, so contributions should be very easy. However, there's an RFC for this, which is, I think, almost there. So I really hope that gets accepted soon, so we can move on and enjoy those improvements. And last but not least, there is a lot of work has been done on improved error messages. More on this later. And I think that also will impact a lot on the experience. So what I do think is missing for documentation is the following: tutorials. So a lot of this is focused around people getting into Nix and really making sure this experience is best possible. Right now, you have to go kind of through manuals to find ways to start. Really, really big feedback that I hear all the time is people have no idea in which manual is what. So we either merge them or we provide a search through them. I prefer for the merged option, but either of those will do. And then a way to attach documentation in code and a way to generate documentation from Nix files. And then frequently ask questions. I think that's, I like that saying, a common knowledge is what everyone knows except you. And I think this is very true for Nix. So I think getting that written down is really important. And the last bit is that reference and narrative documentation. So documentation that tries to explain things is still a bit mixed and it's hard to reach. So I think if there is one thing that's really important from this whole talk, I think it's this slide. This will make the biggest difference to the people coming into Nix. So just to give you one idea of how documentation can also impact experiences, this is documentation I wrote when people use cachex and they are not getting results from binary cache. You can see the procedure is quite complex. Now, some of this could be automated, and that is my plan. But I would just like to know that documentation also exposes how some things are more complex than they should be. So in this case, you have to check if the hashes between what you're requesting and what you're expecting in binary cache matches. And you have to check if you've reloaded the daemon or not. You have to check if derivations allow substitutes in the first place, and so on and so on. So I could, documentation could be its own talk, but since I only have, a few more minutes, 10 minutes, I wanna jump onto installation. So I think the biggest, how to really phrase this, the biggest problem we have right now is that installation has this matrix of multi-user, single-user, sandbox, or no sandbox, and then also different platforms. And that's already a huge matrix of possibilities of things going wrong. So a bit more about this later, but I think this is more complex than it needs to be. Besides that, the installation for daemon and versus no daemon follow different principles. One of them can be reinstalled, the other one cannot be reinstalled. And if you go through the Nix bug tracker, you'll see there's a lot of cases still when things don't work. This has been proven through the last years, but I think it needs way more attention. For example, the macOS users with a specific chipset currently cannot even install Nix, and as someone coming to Nix ecosystem and a company with, let's say, 20 people, that's a huge problem. How can you then expect the whole company to use Nix? This is really huge, I think, for adoption. Something that I think there were just recently talks how to improve this, so I'm really glad and thank you for working on this. And yes, because of the installer, installation and upgrades are painful, too many options, too complex, and yeah, the last one I already mentioned. So I don't have really a good proposal for this, except it needs attention and work. I think the biggest one, which I'll talk later about, is that the multi-user and versus single-user support provides most of the headaches. And then, as mentioned, command line interface is the new command line interface is really, really nice. But it's been experimental for I don't know how long. I think it's been 2 years already. And with Flakes coming in, I think it's going to take even longer. So what I think needs to happen here is just to wrap up the feedback and get it released. It's a lot better than what we have right now. If you go through tutorials that I'll show later, you'll see that some of the really easy things that should be easy are really complex with the current command line, and with this one there, as one would expect with a package manager, a simple interface. Convention over configuration, I think, is something that Nix needs to adapt, and I'm really grateful to see Flakes really have this in mind, and I also am glad with the new module system that things are getting a bit more semantic. What I mean by that is, an example is, if you have a default .nix package, what is the return type of that package? What do you get back? Do you get a single package that this whole project is supposed to install? Do you get an attribute set? What's inside this attribute set? So these are all the questions that Flakes answer. And I think it's really great that the module system will also bring this mindset to the, being able to expose more things about packages, provide, searchability, discoverability, and so on. I think one area where we don't have a lot of focus right now, but also would be even more impactful, is language support unification. This is where there are different ways to package, let's say, Python, JavaScript, and other different languages in Nix. And the interface, how that's done, is different per each language. Moreover, there are different approaches how this can be achieved. So I think Nicola had a pretty good talk last year about this, and it would be great to have that written down as documentation, and then these projects classified as such. And with the new module system, or hopefully even before that, having an IRC that would unify this, so that if I'm working on Node.js or Python or Haskell, I get pretty much the same API, and I don't have to relearn that API over again. I think that's a huge cognitive overhead that adds a lot to the learning curve adoption that people were talking about. The language, I think people can grasp. It's not that, I mean, it is a functional language, sure, it has things, but the fact that you just switch to a different language support and you have to like reread the docs and figure out everything, that is huge downside currently. And this is probably the most controversial bit of my talk and something I don't expect to happen, but I think a lot of features could be removed that would also improve adoption. With Flakes, I really hope the Nix channel goes away. There's so many bad things about Nix channel that I don't really want to go into, and in my tutorials I was always avoid it at all costs. And I think that will happen as we adopt Flakes. Imperative package management and multi-user support are the two controversial ones, I would say. I think if we had a really good story with declarative package management, imperative package management wouldn't be that much needed. That's probably a really long debate, but back to what I said, do one thing well. I think already here we have a split again, and multi-user versus single user, the same story. Supporting multi-users installing is great. No other package manager does that, but it makes everything complicated. It makes installation complicated. We have to try really hard to support that. And it makes also support and questions really complicated. Like this, let's say nix.conf option. Does it apply to the daemon? Does it apply to the client? Does it apply to both? What's the context there? A lot of complexity to support that. We can have multi-user story, which I'm sure some people are using that, but the old package manager that go through sudo and so on work as well, I think. Yeah, so I don't have a really good solution for this one, but I definitely can see complexity in Nix because of that. All right, and then I want to mention the 3 things that I've been working on in the last year. First of all is nix.dev. It's an opinionated guide for developers getting started and wanting to get things done in Nix ecosystem. There is a getting started template. There is a bunch of tutorials. I plan to write 5 to 10 more. I had a bit of a pause now in August and September, but I plan to get back to that. There's a lot of anti-patterns and FAQ. So far the feedback has been great. With Ben Burdett, he's doing all the hard work, running a campaign to improve Nix errors. You see a bit of result from that work already in Nix Master. Here's a screenshot of that. You can see the source now, where it's coming from. And right now, you can still donate, and that time will be spent on specific errors. You can also send us a link to the errors you'd like to see fixed from Nix issues. And yeah, this is a long-term project, and I'm really grateful for everyone that donated. I think we gathered about $4,000 so far. And Ben is going to do some work still based on the last donations. So if you want to see more of that, yeah, please donate and send us the links. And then last but not least, this is the work that allows me to work on Nix full-time currently, is the infrastructure project cachix.org for binary cache hosting. It has about 9 terabytes of monthly traffic right now and growing. Over 2,000 developers have signed up. It allows public caches. These are mostly meant for open source projects. Keep using them for whatever you do. I'm really grateful every time I see a project using cachix and saving that time from developers. And private caches are meant for protecting proprietary code so that you can use it in a company or other setting where that's appropriate. And it comes with a CDN with unlimited bandwidth, so you essentially just pay for the storage in different plans. And there is a way to integrate in the various continuous integration systems, and the docs are at docs.cachix.org. What I plan to work on next is a bit better fine-grained way to authorized access just to a specific cache, organization support, and native support for Nix copy. So the HTTP binary cache protocol, which is a lot slower and less efficient than what Cachex currently does, but this has been requested so far a lot of times that I'll be and try to support. So that's very briefly and quickly in 25 minutes. I think the gist of my talk is we have to focus on documentation, installation, and command line. And I think things are spreading out now to flakes, to content addressable storage, and a lot of things. And I think it would be really good to get those things in order first.
Yeah.
So thank you.
So it does seem you did run over the time, and let's see. Questions. As for the questions, I don't see a ton of questions. I do see one Cachex related question. So maybe I can send that to you, and I also have my own questions also. Okay, so are there a local hosted version of Cachex or something like that?
Local. So you cannot host it yourself. Because it is closed source, the server part, but I do offer on-prem, given that you are willing, of course, to pay extra than the cloud version, if that's something that you require.
Right. I actually use Cachex, so. Okay, so I actually found myself agreeing with almost everything you said throughout this talk. Yeah, from the perspective of a Nix developer, all of this makes like really good sense, and I always find that these types of talks are really interesting to also watch in like the future. Like I think I saw a talk by Rock from like a couple years back, and it was like really interesting to see where we were now compared to what that talk focused on.
Yeah, we'll see. I mean, I had a talk in 2018 where I say the focus is on documentation and infrastructure. And the infrastructure comes first because we somehow had to get the funding to fix documentation. So 2 years later, I think that part is checked off. So now onto documentation.
Right. I feel like you said with documentation being able to like be a format that developers would love to touch is going to change a ton of things for sure. So we would love to see that RFC actually get accepted. I'm anticipating it.
Yeah, I think it will. I mean, the feedback has been that way, and I don't see any reason why not. I'm confident about it.
I see someone's question. They're asking like, how does one actually get started using doing documentation? And currently, I would say that trying to do the current state of things is actually really, really difficult. So if it were a markdown situation, it would probably be much, much, much easier, and it would get written much quicker.
Yeah, I think the answer to that is right now, it's extremely hard to make big changes. This is why also I've started Nix.dev project as a separate one, because I just wanted to get it done and not argue or discuss too much about how it should be done. But I hope with the RFC, we will get in the right direction. My suggestion is start small, contribute small improvements, just small steps. That already is a huge help.
Right. I have another question here, and it says, in your opinion, if you had to pick one, what's the single biggest bottleneck for stabilizing new features faster/going faster as a community? I'm not sure how you'll exactly answer that one, but you can try.
I think the biggest one for adoption would be documentation for people who are getting started.
Right.
And that's number one by far. And yeah, then the rest of the two follow.
Okay, I do see them. I get type notifications, so I can see someone is actually typing a question. I don't think we'll have any more questions for the Q&A portion, I believe. So, Gilman, thank you for being here. I really did actually enjoy your talk. Like, as a actual contributor and a former and current release manager of NixOS, all these things are like definitely right in my mind as well.
Thank you.
Yep,
I'm glad.
everyone, you already know what to do in the NixCon channel. I don't have to say it again. And if you'd like to continue discussing with Doman, and maybe you're not aware of this, but there is the breakout room, which is change-ecosystem, which we'll be forcing you into. So if anyone wants to continue to like ask you any questions or discussion, you can link there and continue.
Awesome.
Okay, great. I don't believe we have a 5-minute transition, so we will have to go to the next talk immediately. Okay, I think I'll have to hop out of this room. I'm sorry about that. Yep, just tell me when.
Hello, I'm here.
Yep, sorry we run. Okay. So hello everyone, back again. So this talk is remote deployments with NixOS and NixOps at YabberTech. Oh, sorry, my apologies. I was thinking I was looking at the wrong portion of the script. Okay. So our speaker today is Aiden Seaman, and his talk is going to be about what he does at YabberTech and some of the software and computer-related challenges that this brings, and the aspects of NixOS that help us address these challenges and why we choose it, how we use it in practice, and our experience of having used it. So similar to a talk we might have had earlier about applied Nix at work. So a little bit about Aiden is he is the CTO of YabberTech. So that's interesting to be able to have him here. And he is a software developer, engineer, and physicist by training. He's been using Linux since 1994 and Nix for the past 2 years. And he is passionate about math, computers, functional programming, and just open source software in general. And fuck, I believe this is a pre-record situation, so I will let you feed that in.
Hello, my name is Aiden Seaman, also known as Henson on Freenode. I'm the CTO of YabberTech, and I'm doing a presentation on remote deployments with NixOS and NixOps at YabberTech. At YabberTech, we make a baseball tracking system that tracks pitches and batted baseballs and measures the trajectory of the ball and its spin rate and axis. This gives baseball coaches information on how their pitchers are throwing the ball and the aerodynamic effect of the spin that they put on the ball. For our in-game systems, we use 4 machine vision cameras running at 200 frames per second to give us a 3D stereo view of the ball at the pitching rubber when it leaves the pitcher's hand, and at home plate when it comes in to the batter and is hit by the bat. These cameras are installed on the side of the baseball field and allow data to be captured during an actual game without being obtrusive and interfering with the gameplay. Our software is written predominantly in Python, with some parts in C++ and some additional parts in Haskell. Our software runs on regular PCs running Linux. We used to use Debian for our old systems, but all of our in-game systems now run NixOS. Let me tell you about some of the challenges we face with our systems. Our in-game systems are usually installed in baseball stadiums, usually in environmentally protected enclosures on the wall of the dugout. These installations are remote, headless, industry-grade PCs without any moving parts. Some of our installations use regular PCs in a more controlled environment. We need to provide connectivity for our customers to connect to the ball tracker with the data display tablet to see the pitch data the system collects, and for the ball tracker to be on the internet for monitoring, data collection, software upgrades, and maintenance. We have to deal with a variety of different network connections based on the facility where it's installed. Some places don't have any network infrastructure at the field, and so we need to use a cellular modem to connect the ball tracker to the internet. These places also don't have any Wi-Fi infrastructure, so we need to provide our own Wi-Fi access point to which the customer connects the data display tablet. Other places do have network infrastructure, in which case we will connect to an Ethernet connection for internet access, and will either provide our own Wi-Fi or, more often, connect to their Wi-Fi infrastructure and provide customers with a direct Ethernet connection or Wi-Fi connection through their facility's network. We need to keep a constant watch on our systems to make sure they're operating properly and to detect any failures or problems. We use Zabbix to monitor these systems and provide us with a dashboard that indicates any malfunctions that are detected and provides us with the ability to look at historical data. We keep all of our systems up to date with the latest ball tracker software. In order to do this, we need to ensure the safe installation and upgrading of our software on the ball tracker computers. In addition to being able to safely install and upgrade our software, we also need to install and upgrade the various other programs and libraries on which our software depends. To prevent our operating system from becoming outdated, we need to be able to upgrade it too, as these computers are intended to be in use for many years. We also want to be able to make multiple deployment tracks for our systems, so that we can roll out new changes to certain customers willing to help us test new things before rolling them out to everybody. We also want to have a consistent execution environment for all of our systems. For consistency and ease of debugging and reasoning about problems we encounter, we want the software to behave the same way in the ball field as it does on our development computers. Finally, we need to administer many deployments throughout the United States, monitoring them, collecting data from them, troubleshooting any problems that arise, and keeping their software up to date. Now let me tell you about how NixOS helps us address these challenges. First of all, NixOS makes it easy to configure the system in a consistent way. We don't have to edit a lot of individual system configuration files with different syntaxes and file system locations. This eases system management. Everything is specified in the configuration file stored in /etc/NixOS in the same Nix expression language. This single configuration location allows us to unify many heterogeneous components under one configuration umbrella, propagating common variables down into the different components of the system. The Nix expression language also allows us to catch configuration errors at build time using syntax checking, assertions, and variable type constraints. The modularity of the NixOS modules allows us easily to enable or disable chunks of functionality based on the configuration needs of a particular system. We can turn on and configure a certain functionality as simply as writing enable equals true, and then filling in the various non-default configuration options in an attribute set. This simple change might then install some new custom software, as well as the support libraries and software that goes along with it, and configure a cron job to run at a certain time while relying on some global configuration options. Because the Nix language is just text, we can easily keep track of it with Git. This allows us to see when changes were made to systems, as well as experiment with a particular system's configuration and then revert it back with a single Git command. One of the great things about Nix is that it delivers us from dependency hell. No longer do we need to worry about the libraries our software uses being a function of the operating system version we're using. We don't have to upgrade the OS in order to take advantage of a new library, nor do we have to upgrade our software in order to move to a newer OS. Like FreeBSD's separation of system software from user software, Nix allows us to separate all software from one another, allowing each one to exist in its own little bubble. One of NixOS's great strengths is the ability to make atomic changes to the installed software, and nearly atomic changes to the running operating system. This frees us from the worry of having a system that is in an inconsistent state due to a failed software upgrade, neither where we started with the old software nor where we wanted to be with the new software, but at some non-functioning intermediate state of limbo requiring time-consuming manual recovery. On top of this is the ability to roll back changes to a previous state, not only for our software, but for the entire operating system and its configuration. It's even easy to roll back after doing an operating system upgrade from one NixOS release to another. Try doing that in any other OS. One of the design motivations behind Nix is the creation of reproducible software environments. This allows us to run the exact same software in the ball field as on our development systems. It's just a Nix shell away. To help us manage our many deployments, there is NixOps, which allows us to scale all of these benefits up from a single system to a whole bunch of systems. NixOps gives us the ability to build our software locally on our development systems and then upload them to the remote systems. NixOps provides the ability to tune how you deploy your software, including building only, copying only, dry activating to see what changes would be made, testing the changes out without making them permanent, and finally making the changes permanent. This allows us to test new things in a conservative manner to make sure they work properly to avoid breaking systems due to software or configuration problems. We worked with G. Christensen and Addis Blattis at Twig.io for a sprint, and they added a feature to NixOps that allowed the automatic rollback of the system configuration in the event that the system becomes unable to communicate due to a configuration change. We researched different mechanisms for deploying consistent and self-contained software to systems, such as Docker, Snap, and AppImage. These suffered from the problems that all of the software had to be bundled in one big chunk. Any upgrades to our software environment would have to be a large download that sent over all the dependencies again, even though only one small part may have changed. It was not possible to layer these environments on top of one another. NixOS allows us to have a self-contained software environment while transferring only derivations that have changed, giving us considerably lighter weight updates. NixOS gives us atomic changes, not only for our software, but to the whole operating system. The ability to roll back is a very compelling feature, allowing a quick recovery from any software or system configuration errors that may arise. Finally, a thing that no other distribution offers is the ability to upgrade the entire OS in a safe and consistent manner, including the ability to roll back in case of any problems. Amazing. Now let me tell you a bit about how we structure our software in NixOS. First, we have NIV, that specifies a Nix packages version that our software uses, as well as a version that the operating system uses. These go into the Nix packages sources. Our custom software derivations then get overlaid on these Nix packages, which allow them to seamlessly make use of these different package sets from their packages variable. We also have our own custom NixOS modules. These Nix packages and our NixOS modules then get imported into the NixOS system configuration on a particular machine, and are combined with the desired NixOS configuration options. This NixOS system is then put into a NixOps deployment, which then gets built locally and uploaded and installed into the remote system. Now I'll tell you a bit about how the different software profile tracks work. First, at the top we have our NixOps deployments, which are in a Git repository. Let's say we have deployments 1 through M. Deployments 1 and 2 use the release profile. Deployments 3 and 4 use the testing profile. Deployment M is using the experimental profile. The release and testing profiles check out different versions of our custom Nix packages Git repository. This allows them to see different package sets in NixOS modules. In a particular version of the Nix packages repository, the various software derivations will check out a particular version of its respective custom software, which is stored in a different Git repository. These are the Git repos 1 through N. This allows the testing profile to use completely different, or perhaps slightly different, software and NixOS modules compared to the release profile, all while existing in the same NixOps deployment. When we want to move a system from release to testing, it's as simple as changing a single line of text. To move the testing profile from one set of software to the next, it's as simple as changing a Git hash string. The experimental branch points to a live directory for the custom Nix packages, which in turn point to the live directories of our software. This allows us to make changes on our development systems and test them on experimental systems without having to commit them to the repositories. Once we're satisfied that the experimental version works properly, then we commit the changes to the various repositories and then bump the Git hashes to move the experimental versions down to testing, and usually testing down into release. Since our systems are deployed remotely, we want any changes we make to be safe and not to result in the system becoming inaccessible. For any big system configuration changes, we usually set a reboot timer and then run a NixOps deploy in test mode. Not only will NixOps cause the system to revert after a few minutes if it becomes inaccessible, but the timed reboot will cause the system to reboot back into the previously good state, as the test deployment does not make any permanent changes. The atomic-like system configuration changes allow us to make large changes to the system networking and to be confident that NixOS will make the necessary changes happen in a consistent way that will ultimately result in a system that can still be reached. I'll now describe some of our findings after having used NixOS for several months. First of all, I found the learning curve to be quite brutal. As Nix and NixOS are quite different than the way most Linux distributions work, it was a challenge even to figure out how to install a specific version of software, or to figure out what package provided a certain thing I wanted. In hindsight, if I had read through the NixOS, Nix packages, and Nix package contributors manuals, I would have been able to understand it more rapidly. A lot of things are not documented very well, and in many cases you just have to read the derivation or module source code to figure out how it works. It also didn't help that one of the first things I tried doing was taking some closed binary libraries and using PatchElf to convert them into NixOS packages. That is definitely not mentioned in any manuals. I find that NixOS systems are much easier to maintain than the old Debian systems. Knowing that, when the time comes to upgrade the OS, I won't be faced with a failed distribution upgrade is a big relief. It's also one of the reasons why I moved my laptop and cloud servers away from Debian and Ubuntu to NixOS. NixOS causes more upfront pain in trying to figure out how to configure things the NixOS way, but once you've got it, you'll never have to manually repair a half-upgraded Ubuntu system by installing 100 packages with dpackage, multiplied by the number of deployments you have. We never have to worry about libraries becoming unsupported due to the connection between the libraries we're using and the OS we're running. We can keep our software running on the same set of stable libraries without needing to hold back upgrades to our operating system. Due to NixOS's atomic configuration changes, test deployments, and rollbacks, I've never had a system become inaccessible. I've been able to convert a couple old Debian ball tracker systems to NixOS using a kexec takeover. Thank you to Clever for sharing his kexec Nix derivations with me. Some pain points we experience with NixOS and NixOps is that once a system is under NixOps control, we can't really locally tweak it from its /etc/NixOS directory anymore. In practice, this hasn't really been a problem, but it's too bad the two aren't compatible with each other. A current pain point is that we need to structure our derivations such that any configuration options coming into it doesn't trigger a rebuild. Some of our software is time-consuming to rebuild, and rebuilding a new version each time we change a configuration string is a real pain. Careful structuring of our software and using wrappers to pass configuration options in by environment variables or command line options can alleviate this problem. Here are the credits for the baseball field picture I got from Wikipedia and the ThinkPad picture I got from Flickr. Finally, a big thank you to everyone on the NixOS channel on Freenode. I would have given up a long time ago if it wasn't for your helpful answers to my many questions. And thank you to the NixOS community for all your hard work in building this great operating system and software ecosystem.
Hello, we have Aiden here for the Q&A portion of the talk, and I'll be jumping in reading off the questions right away to you.
Okay.
So the first question we have is the name Yakutek derived from the Japanese word for baseball, yakyu?
I'm not sure if it's derived from the Japanese name, but there is a type of ball, a pitch called a yakker ball in American baseball. It's not very well known, and a few baseball people who we talk to know about it, but it comes from the name yakker ball.
Interesting, right. So the next question we have is, what system architecture do your industrial PCs use?
They're just regular PCs. Regular Intel PCs. They're like, I think, i7s, usually like 8-core i7s. They're by a brand called Nusys. They're the Nuvo 7000 series, and so they're just they don't have any moving parts. They have a humongous heatsink, so they don't need fans, and they're good to operate at high temperatures, and they're just extra tough computers.
Yeah, those sound pretty cool. Okay, so the other one is, you mentioned a live directory mechanism. How the changes are picked up by this live directory? Is it an NFS directory? If I do a commit on experimental branch, how does it get picked up? I feel like it's rolled many questions there. I hope you can handle that.
Okay, that's fine. On the non-experimental branch, the directory that it looks in for the default.nix file, for example, on the non-experimental, those come out of a Git repository, and so then it looks in that Git repository for the default.nix. But on the experimental version, it just looks in an actual directory on my computer for the default.nix. So I can change things in that directory without without it having to be committed, and those changes are picked up by Nix, and I can just rebuild them. And then that live directory is actually the repository that the changes get pushed into, which the non-experimental versions actually check out. And so whenever I'm satisfied with a experimental change, then I just commit that and push that out to the sort of remote where it's stored. And then the other branches are able to pick up on that commit that I've just made.
Right. I believe you answered all those questions perfectly. Okay. So rolling your own Nix packages repo / not using official channels, how much real building do you have to do versus leveraging the official cache?
Well, only some of our packages are custom packages. And so we do have to rebuild all of our custom packages, obviously. But for the most part, we're able to make heavy use of the existing caches. And for the ones that, for the things that aren't in the official cache, NixOps just uploads them to the target computer. There are some custom ones, and then we ones that get reused, and so we just bundle those up into like a bzip nar file and store them in one of our cloud computers, and then just push those out to the systems that need it. So it's kind of heavy use of the official caches, medium use of like an unofficial just SSH or secure copy with a Nix store import, and then NixOps pushes all the rest of the stuff in.
Right. So the next one is is this slide related? So it says, do you have references to the NixOS bootstrapping via kexec part?
Yeah, I can post the link to Clever's GitHub repository where I got those things from.
Okay. Do you do secure boot and enforce rootfs integrity, like with DM verify? I think that's the word right there. Might be a misspell on your industrial PCs.
No, we don't do secure boot.
Yeah, I think there's also a connected thought, but I will not mention that. So, could you explain a bit more how you kexec from Debian to NixOS?
Yeah. So I experimented with this first before using Clever's derivations, but Clever's derivations are very nice in that it sort of bundles it all together in a simple like Nix build sort of script.
Clever is so clever.
And so what you do, Linux is able to, there's the kexec tools package, which allows you to have like a bz image and an initRD image. And then Linux, while it's running, is able to take these, load these into memory, and then essentially like instantly stop its operation and boot into this new kernel and load up the new initRD. And so all you have to do to take over a computer, which I've done with a couple actual computers and several cloud-hosted computers. For example, the cloud-hosted computers often don't have NixOS as an option. And so you just install Debian and then upload your kexec stuff and then do this thing to take them over. And you have to be connected to like your sort of KVM terminal on your cloud computer. And then you're able to sort of continue typing and do the NixOS installation. But once you load this kexec thing into memory and then run it, it will. You might be able to see my cat here. It will then instantly reboot, and you're essentially just dropped into a NixOS installation where you can then do the install, and you can reformat the hard drive and all that kind of stuff. The only caveat is that if your computer turns off for some reason partway through the install, then your computer's hosed.
Okay, right. If you want to adjust your cat, oh, it looks like they walked away. Yeah. Perfect. They got the cue. Okay, next question. So there's a question here about auto patch elf hook, which is a hook infrastructure that's inside of Nix packages, and they say it should be less painful than using patch elf manually. So have you considered actually using that?
I have. I have not done that. When I first started doing this, I've only had to do it once. It was when I was beginning learning Nix, and so I didn't encounter the auto patch elf. Doing the patch elf manually I had to make some other little scripts which would check to make sure that all the libraries that the thing depended on had been converted over to the appropriate NixOS libraries. And so it was a real manual sort of procedure. But once I did it, the 2 times that were required, I didn't have to do it anymore.
Right, so it's like don't refactor when it's going to be more work to refactor in the first place. But
Exactly,
actually, I think using auto patch elf hook is actually pretty simple too. I think you just add it and have the dependencies and build inputs.
Okay.
Okay, I have another question which is being live formatted, so excuse me if I just take 1 second to sort of read over it to make sure it's not completely difficult to pronounce.
Okay, I see it here.
Okay, so it says, is it possible to locally configure systems developed with NixOps? You can just copy the configuration to the remote machine in an activation script. And then there is a, it appears to be a blog post referencing auto upgrade with NixOps and NixOps.
Okay, I will copy that and we'll investigate that. Because that could be very helpful.
Yep, noted. So I don't think we have any more questions. I can check the channel to see if there's any noise in there left. There's one more. It says, how many people are there with you that manage all these servers? So just a staffing question, I guess.
Just one, just me.
Just one. Okay, just you. Okay, I think that okay, I have a missed question. Sorry. So, can this hardware be core booted, or was that asked already? I'm not sure.
What does core booted mean?
I'm trying to actually remember which core boot is. I think that might have to do something with like AI, like a firmware platform. If you don't know what core boot is, then I guess you won't have to answer this question. It would definitely be a no then.
Yeah, I don't think so.
Okay, I guess that concludes your Q&A portion. Thank you so much. You had a very lively Q&A session here. It was literally coming in as I was trying to give it to you in some points.
Okay, well, it was my pleasure.
Yep, great. Thank you. Okay, and remember everyone's make some noise in that channel for Aiden. Okay, I think I might need to transition to the next room. Sorry about that once again. And this next one will also be a pre-record. Hello, sorry about that. I wasn't exactly keeping track of how long that Q&A session was since it was so interactive. So we have just like a 2-minute break here, and then we will have Daniel's talk in a moment. Okay, hello. That was like probably the briefest transition ever. So we have Daniel Fulmer, and his talk is called Robotniks, Build Android AOSP using Nix. And the topic of his talk is that Robotniks enables a user to build Android images using the Nix package manager. AOSP projects often contain long and complicated build instructions requiring a variety of tools for fetching source code and executing an incredibly convoluted one, like it was mentioned. And just some brief background about Daniel is that he started using NixOS in 2015, and he just really liked the model and just got into it right away. He was a recent graduate from PhD from Yale for electrical engineering and focusing on control theory and distributing compute. He also started as a chief scientist at Achilles Heel Technologies this year, and his interests outside of NixOS are actually weightlifting and powerlifting. So yeah, that's pretty cool. Take it away, Puck.
So, Robotniks is a project I've been working on over the last year to year and a half, which aims to build Android, or more specifically the Android open source project, using the Nix package manager. And before I go to Robotniks, I want to briefly describe how you might go about building Android by following the instructions on the Android.com website. So, to begin, they recommend that you use Ubuntu 18.04, and like many projects, they have you apt-get install a whole set of dependencies. Additionally, there's a tool that you need to get called repo, or git repo, which will fetch the Android source code. And this is the tool that manages the large collection of Git repositories and Git trees and puts them into a single source tree. So in order to use this, you need to create a directory, run repo init, and then repo sync, and download roughly, if I recall, roughly 40 to 50 gigabytes worth of source code. And you'll have to know the name of the Git tag that corresponds to the latest Android release. And finally, to build the code, and specifically, we'll have it built for the Google Pixel 3 XL, which has the code name of crosshatch. You can run those following 3 commands. And then wait for a very, very long time. On my old computer, it used to take roughly 8 hours. I got a much faster computer that can do it in just over 30 minutes. But at the end of this process, you'll have a number of build products under a certain subdirectory. And these are the instructions that are on the Android.com website. However, there's a number of limitations to those instructions. So for instance, the kernel and the Chromium web view that are included in this will be in the source tree, and these are pre-built versions of the kernel and Chromium web view, and so they're oftentimes out of date and don't correspond to the latest secure release. It'll also be missing proprietary vendor binaries that are required for your Android image to work on a real Pixel 3 device. And finally, this build wouldn't be signed with secure signing keys. It would actually be signed by a set of keys called test keys, which are just for development and testing. All the issues that I just mentioned, there's documentation on the internet about how to go about solving all of those things, but they're not readily accessible, and they require many more steps, especially for something like building Chromium web view, which is an entirely different build system. So in contrast, Robotniks aims to make this process much more simple. So here to build a Pixel 3 XL image, you'll just git clone the Robotniks URL, and then run nix build by passing a configuration argument, where here we're just selecting the crosshatch device, which corresponds to the Pixel 3, and we're choosing the vanilla flavor of AOSP. And then you can flash the resulting image, after it finishes building. So it's much simpler than the standard sets of instructions you go about for building Android, and it includes all the dependencies and handles all of the tricky complexities about integrating all of those sets of projects. So you might ask, why would you want to use Nix for doing this sort of a thing? And Nix in particular for this type of a project is very good at integrating all of the diverse build tools across all of these diverse project ecosystems, including Android and Chromium and the Linux kernel. It also has great guarantees around the reliability and reproducibility. In particular, the default Nix sandbox ensures that your code is depending only on explicitly defined inputs. So Android 10 actually does a little bit of sandboxing of their builds now with a tool called NSJail, which at least disables network access, which has been quite nice for the rest of the Android ecosystem, because it restricts them from being able to have a script that just goes and randomly downloads some source from somewhere else. You have to have everything at the beginning of the process. And additionally, in Nix, we'll require all of the build inputs to be hashed, and we can't sneak in any impurities in through other means. So then some of the broad goals of the Robotniks project are simplicity. I'd like it to be very simple to use. You shouldn't have to know anything about the Android build system or the Chromium build system in order to use Robotniks and build Android images. Additionally, I'd like it to have some measure of customizability, and I recognize that is somewhat in conflict with the goal of simplicity, but I hope that we can toe a fine line between the two values. Another goal that I have is on reproducibility, and here I mean bit-for-bit reproducibility, by which I mean any two people should be able to, if they build the same configuration, they should receive the exact same output, bit for bit. There should be no difference between the output files. I'm also interested in authenticity, specifically the authenticity of the build inputs, that the source code comes from authentic sources, and specifically some of those proprietary vendor binaries that I talked about previously. I'd like to get them from authentic sources, like, for instance, the vendor themselves. Additionally, I'm interested in security and privacy. Robotniks doesn't do anything particularly new in terms of security on Android, but we at least try to maintain the Android security model in terms of things like Android verified boot, for instance. This is in contrast to some other projects, other popular projects. And additionally, privacy, because we're building open source Android builds that don't include things such as the Google Play services. We potentially mitigate a number of privacy threats. So returning to that goal of customizability, Robotniks uses like a NixOS style module system that allows us to select what options we want to enable or disable. And here I've included a example configuration, and I'll discuss some of these options in terms of each of these modules in the coming slides. Some of those modules including things like choosing which flavor to build, things having to do with Chromium and WebView, the Linux kernel, and others. So the flavors that Robotniks currently supports is we support the vanilla AOSP. This is the source directly from android.googlesource.com. And this has been updated to the Android 11 release, which was released last month. And it focuses on just the Pixel phones for now, the Google Pixel phones. We also support another Android project called Graphene OS, which is a privacy and security focused project which does a number of hardening of the Android operating system. And it also is on Android 11 and focuses on Pixel phones. Finally, there's probably the most popular Android project, Lineage OS, which I added a couple months ago in what I call experimental support, because I don't personally use Lineage OS, and so some of the Lineage OS things might conflict with some of the Robotniks modules, and I haven't tested all the combinations of those things yet. But I believe it's still on Android 10. I don't believe any devices are on Android 11 yet. But however, Lineage OS has a great support for a very large number of devices. I already talked a bit about how Robotniks builds the Chromium and the Chromium WebView from source. So the Android system WebView is the component which allows all these Android apps to display web content. And it really is it's a necessary component of the Android system. You can't really build a usable Android image without having Android WebView. So it's nice to be able to build it from source. And in fact, we can build a couple of Chromium forks, including Bromite, which focuses on privacy, and Vanadium, which focuses on security as well. I also have some options to enable custom Linux kernels. You can have your kernel source come from any other source tree, as well as allow you to easily patch the kernel that's included in the Android build. Additionally, we enable you to easily sign your build with your own custom generated keys. So you can have a set of Android signing keys which you control and only you control. And these keys are would be necessary for you to sideload updates or do over-the-air updates. In that way, you can control the software that runs on your phone. It has to be signed by keys that you control. Additionally, Pixel phones have a very nice feature with regard to the verified boot, where they allow you to they have a user-settable root of trust, which corresponds to your custom Android keys. So this is all part of the verified boot sort of methodology, where you have a read-only system image, and any modifications of that image have to be signed by keys that are trusted in this very low level, below the bootloader even. There's also a module that allows you to do over-the-air updates. There was an updater app from Graphene OS which has been incorporated into Robotniks, and we allow you to set a custom URL that this can check for updates against. So it needs to point to a directory containing those update files as well as some metadata, and we have a simple derivation that allows you to easily create such a directory. There's also a module for F-Droid, which is the free and open source Android app repository. It also comes with a privileged extension, which allows you to easily install apps without having to enable some of these extra options, like the unknown sources option. In a similar way, like the Google Play doesn't have this restriction. Additionally, the privileged extension allows you to install updates in the background without having to go manually click install on every single update that you care about. There's also MicroG, which is a re-implementation of a number of Google's proprietary Android user space apps and libraries. So this re-implements parts of the Google Play services. A number of apps, unfortunately, require Google Play services to work, but I've tested things like push notifications through MicroG work well in Robotniks. Finally, there's also a very nice backup system called SeedVault Backup, which uses an internal backup API. And like on the Android images from Google directly, where you can back up application configuration to the Google Cloud, SeedVault similarly allows you to back up application data to like a USB drive or to a hosted NextCloud or something like that. And then there are two more sort of generic modules that I want to briefly discuss. One of which allows you to easily add additional source directories to the build itself. So here I have an example of extra-dir. You just set a .source, and that can be the output of any other Nix derivation, and that the output of that would be included in the Android build. Additionally, I have a patches option, which allows you to very easily enable particular patches on some of these Android sub-projects. And because the Android source tree is so large, like I said, 40 or 50 gigabytes, if every single time you had to build Android, like the default way it's done in Nix is to actually copy all of the source every time. I have a little optimization that will do bind mounts to avoid copying the source every single time you want to build Android. And the flavors that I talked about previously, the way those flavors are implemented is they mostly just set up the default sets of source directories. Finally, you can also include additional pre-built applications in the image. So here I'm adding an example application to some example.apk. So naturally, this could also refer to the output of any other derivation. So if you had something that built an application, you could include it in a Robotniks image using this option. And the other options, many of the other modules like SeedVault and MicroG are actually implemented using this apps.prebuilt option. So SeedVault is built from source, for instance. It produces an APK, and then we include that APK using this option. I also have the ability to launch an emulator with an attached Robotniks built image. So here we're selecting the x86-64 generic device and building an emulator, and you can run that directly on your desktop. It's very nice for conveniently testing out some of the other Robotniks options. Like if you want to test out if MicroG works or if SeedVault works, you can do it locally on an emulator. Next, there's the SDK. So the Android SDK, which includes some utilities like Fastboot or ADB, which are used for flashing your phone. Google publishes pre-built versions of the SDK, but they publish them under an additional SDK license. However, if you actually look at the code that goes into producing that SDK, it's mostly Apache and GPL. And in fact, the Robotniks project has a little subdirectory, the SDK subdirectory, which if you build the derivation in that directory, it'll actually produce a full open source SDK for Android, including things such as fastboot and ADB, which would be unencumbered by that SDK license because it's built entirely from permissively licensed sources. So, like I said, one of my goals was reproducibility, and Google actually does a fairly good job with reproducibility of Android builds. Now, there's only a few small patches, mostly concerned with things around signing and the target files and some partition impurities. And so in the past, like a few months ago, I've verified that the output of Robotniks is actually bit for bit reproducible for both the Pixel 3 and the Pixel 1 on the vanilla flavor. But Lineage OS, we also have some patches to fix a few small impurity or non-reproducible components of that, and we've tested it to be reproducible on certain devices as well. But a thing that I'd really like to do at some point is to have like an automatically produced reproducibility report, kind of like the R13Y report for the NixOS minimal ISO. I think it'd be very nice to have that for Robotniks as well. And so the remainder of this talk is going to be some ideas for future work on Robotniks and more speculative things in the future. So one of the big sort of limiting factors for building Android is the requirement that you have a fairly powerful computer and can fetch a lot of source code. Robotniks builds most of the Android in a single very, very large derivation, which executes that full Android build process, and on many machines will take multiple hours, up to 8 to 10 to 12, depending on what exactly you're building and how powerful your machine is. But once you've built this derivation, the signing step can actually be done on another very small derivation that just depends on the output of that large derivation. So you could do something like publish the output of that large derivation, a certain set of files called target files, publish it up on S3 or CacheX or any other Nix binary cache, and then allow users to depend on those pre-built versions of the target files, but then still sign those target files with their own locally generated Android signing keys, which would enable them to have a lot of the benefits of customizability, still being able to control their own keys, but not necessarily have to rebuild the entire thing themselves. But of course, there are some obvious downsides to that approach, which is that the output is quite large for every single build, a bit over 3 gigabytes. And every possible configuration of Robotniks produces a different output. So if you wanted to make a build for every single combination of Robotniks options, you'd have an exponentially increasing number of options for every single new option you enabled. But maybe you could do something like publish a smaller subset, like maybe just 1 or 2 configurations per device, maybe a minimal configuration and a more full-featured configuration per device. Here's quite a bit more speculative thing that I'm quite interested in, which is that if we know that the output of Robotniks, the target files output, are bit-for-bit reproducible, we could do something like have multiple independent builders, each of which is producing their own unsigned target files, but then have them sign those with Nix binary cache keys. And there are a couple Nix subcommands that looked quite interesting. I haven't looked into this in full detail yet, but you can do things like verify that a certain number of signatures apply to a particular derivation output. So instead of trusting that a single build farm or build server, you could distribute that trust among a number of build servers and ensure that so long as a certain threshold of those build servers are building it reproducibly and producing the same output, you can have a bit more trust that the build servers are not compromised in a way that they might produce malicious output. And then, of course, like I said, you can still sign this with your own local keys, and you still control the keys that determine what code runs on your device. There's the last thing, which is that build takes place in one very large derivation, and that changes to that Robotnik's configuration will often require a full rebuild. There are some things you can do like Ccache, but it's insufficient for this purpose, unfortunately. If you could share some common intermediate build products between different configurations, maybe you could build things much more quickly. And I'll describe one attempt I have, a somewhat ambitious attempt at solving this with a set of tools. So to do that, I need to briefly describe a little bit about how the Android build system works, which is, in the old days, it was entirely makefiles, but they've added a new build system called Song or Sung, I'm not exactly sure how to pronounce it, based on what they call blueprint files. But they, Song and makefiles, they both, through this Ccache tool, they both produce Ninja files, which are then combined, and that's what's used to actually build the whole thing. But for this, I want to focus on the newer thing, the Song and the blueprint files. And I'll look at an example of what a blueprint file looks like. So here, they're building a binary called ext to SIMG, and it's using the CC binary Song module. And this is a module that builds binaries from C or C++ source code. And I'll point your attention to the sources. You see it's a list of sources. Here it's just depending on one .c file. And then a list of shared libraries. And these are libraries that are defined in other blueprint files throughout the source tree. But if you squint hard enough, you notice that this sort of looks like a Nix expression, right? So maybe if you got rid of the colons and you added equals and added semicolons, and looks a little bit more like Nix. Maybe if you assigned this to a variable and wrapped it in like a let block and added a function header, where you can pass in CC binary, you could turn these blueprint files into Nix files that could then be evaluated by the Nix package manager. And so that's what the blueprint to Nix utility does. I actually modified the blueprint formatter, the pretty printer, to output Nix files based on blueprint files. However, you still have the problem that you have to implement that actual module, the CC binary module. And so I did a partial implementation of some of the modules, the CC binary and CC library modules in particular. I actually can build some of these Android modules entirely in Nix. So the derivation level, instead of a single derivation for the whole thing, you have derivations for each binary and each library. And I can build the ADB and fastboot utilities using the native Clang toolchain from Nix packages, even on ARM64, which is quite nice because Google doesn't even publish native binaries for ARM64 for ADB and fastboot. So already we have a bit of an improvement there. And there's great benefits from using Nix here. Obviously, laziness is great. But the bigger thing is like the derivations only depend on the source files they explicitly reference. So you only need to download a very small portion of the overall source tree to build some of these utilities. This is in contrast to the way it normally works, where you have to download the whole thing, even just to build a very small part. I'll point out this is really a proof of concept and probably not maintainable for all of Android. Like if you wanted to build all of Android using this, it would require more than just me to to implement all of the Song modules and keep them up to date. But maybe you could just do something like the binaries that are intended to run on the host, like fastboot and ADB. And maybe that's something that could be in Nix packages someday. And maybe this could point the way to like a potential future Bazel to Nix or Buck to Nix. There's a lot of other recent build systems that operate in similar ways to Song, and potentially you could convert them to Nix as well. Just for fun, I put a lot of these derivations into Hydra, and just built a ton of things to see how much would work, just for fun. But some of the final goals is like I'd like to set up some continuous integration to ensure that I'm not breaking Robotniks in the future. I'd also like to have some NixOS module or something that integrates with these Robotniks configurations. At the very least, like to automatically set up an update server that will host the metadata in the OTA files. And then finally, I've been using this on my own phone since July of last year on my daily driver, and I haven't lost any data. I haven't had to wipe or reflash this phone. I've only used the over-the-air updates. And so I intend to continue following up with the monthly releases that Google provides to keep it secure and up to date. So at this point, I'm trying to work on making Robotniks useful for other people and not just me. So a lot of that will have to do with documentation, and if anyone is interested in at NixCon over the weekend, I'd love to hear any feedback about pain points or things that I could improve on Robotniks in the future. And then I'm also happy to I got some very good news earlier this week, which was that my proposal to the NLNet Foundation on their NGI Zero initiative was recently accepted. So I'm hoping to be able to do some funded work on Robotniks in the future. I think at this point of the stage we need to define some concrete milestones, but it looks like it's passed the internal and external reviews process. So I'm very, very excited for the future of Robotniks. And of course, I'd encourage you to try it out for yourself. Go check it out at github.com/DanielFulmer/Robotniks. And I'd also encourage you to check out any of these related projects, which were great inspirations for me. And I owe a lot to a lot of these projects. And that's the end of my talk, and I'm happy to answer any questions you might have.
Okay, that was Robotniks build Android AOSP using Nix, and this is the Q&A session with Daniel. So unfortunately, since the talk was a little over the portion, we probably only have time for one question, and then you'll have to sort of do that in the breakout rooms. So let me read the first one. The very first question we have is from Edith, and it says, given that the signing is done in a derivation, do the signing keys end up in the Nix store?
So that's a great question. And I have the answer is no, that they don't end up in the Nix store, but there's a couple things you have to do to ensure that that's the case. So I have two options for how you can go about doing the final signing steps, one of which generates a script, like a release script, that will operate outside of Nix and perform the final signing step. And the other option is within Nix, but you have to enable a certain sandbox exception to enable access to your the directory containing your keys.
Okay, thank you. I guess that was the Q&A session. I am sorry about that. So
No
the
problem.
breakout room that you will be going to is, I am sorry, one second. Yes, the breakout room is Robotniks, so it's just the same as your talk. And the questions that we collected for you, you can if people who tried to give questions would like those answered, I'm sure that Daniel would be happy to do so in the breakout room, so you can get some nice discussion going on your talk. Okay, thank you.
Thank you.
Yep, and we'll be proceeding into the I guess we have about what, 2-minute break until the next talk. Okay, see everyone then. Okay, the next talk up is Bringing NixOS to My School by Mark Schmidt. And this presentation will start with a current state of the learning infrastructure running on Arch Linux and the challenges that we faced with it, the ups and downsides of migrating to NixOS, and what has already been done. So I believe the school that this is about is school that Mark goes to, EPITA, I believe it's pronounced EPITA, a French School of Engineers and Computer Science, and it is bringing NixOS to its students. So it's going to be a presentation sort of showing the challenges of maintaining infrastructure of more than 800 machines used by students. So they started using NixOS a year and a half ago when they were in California for a school trip. That's pretty cool. And they wanted a way to like manage config with like Git. And I know a lot of people like just like Mark tried Ansible, then found NixOS, and I will say that NixOS is much better than Ansible for this kind of thing. And he is also an organizer at ProLogin, the French National Computer Science Contest. And a cool thing we share in common is that, well, I don't play the same instrument, but I am a musician, is he plays viola, and he's done that for 14 years now. Okay, take it away.
Right, so first I'd like to thank the organizers for their work. What they're doing is terrific. So as you said, World of Peace, I am a student at EPITA in my 4th year. I'm part of a laboratory which is called the CRI, which stands for Centre des Ressources Informatiques, which in English means roughly IT Resources Center. So we're also a school department in charge of managing the educational IT needs. What that means is anything from hosting Moodle to managing the computer rooms, which is what I'll be talking about today. Right, so we'll skip over that. So EPITA is still a school that has computer rooms, much like this one. This photo actually is not accurate because now we have screens that stand on top of the tables and that aren't inside, and we are using Intel NUCs as our computers that are attached behind the screen. It's very convenient. However, the CRI does not manage everything in those computer rooms. Indeed, EPITA is part of a group of school called UNIS that tries to mutualize needs, especially in IT. The department responsible for those is called the Bocal, and they manage everything from phones, Office 365 accounts, Wi-Fi, and our computer room's network. This means that we actually have some imposed requirements when managing the computers in those. Our computers used to not have any disk, which meant that we had to boot the machines via network. However, our computer rooms only have a 1 gig uplink for each computer room. And since we have 13 computer rooms across 6 campuses in France, that would just kill our server room uplink that's also 1 gigabyte if we booted all the machines at the same time. So what we're doing is basically having our initramfs that downloads the rootfs using a ARIA2, so BitTorrent. So we don't have to actually download everything from each machine from our server room. So as I said, we have 13 computer rooms. That adds up to about 800 to 1,000 machines, which probably makes it the biggest IT infrastructure running Arch Linux in France, maybe Europe. And to give students some persistence on those machines for the files when they're working on it, we're using Kerberos for authentication on OpenAFS. For those who don't know what OpenAFS is, it's basically a network file system that you can log in using Kerberos, and only you can see your file. It's not like in NFS, right? We also actually have several images that the computers can boot from. We do that because depending on what year you're in at EPITA, you're going to be working with different software, and we don't want to include like all the software used at Epita in one image, it would just be too big. Right now, our images are about 2 gigabytes size, so yeah, you know, all the software would be way too much. Right, so currently our boot process goes as this. So the machines are configured to PXE by default. They get their IP from the switches in the computer rooms, which forward the HTTP request to our servers. Then in this, the HTTP request, our servers tell the computers to download iPXE from our servers again using TFTP. Then iPXE queries a menu from a homemade service that actually manages iPXE menus, which allows us to you know, select a default image for a room depending on what year, what promotion of student is going to be using it. And then once the image has been selected, iPXE will then download the kernel and init RAMFS via HTTP from our S3 servers. And then this init RAMFS will download a torrent file via HTTPS again. It finds what torrent file to download from the kernel command line. And then in this torrent, there is a rootfs squashfs, which it downloads, and then it mounts it and switch roots on it. If the computer has a disk, so our old computers didn't have a disk, but now we have one in our Intel NUC, and we can actually do some boot cache. So we have a partition in which we store the torrent file and the contents of that torrent, and so the machine doesn't have to actually re-download the image if it hasn't changed and it had downloaded it before. Also, once the machine is booted up, there's a service that seeds those images. So a booted up image is capable of seeding its own image and also any other images that it would have been downloaded before. Okay, so how do we build an image? So using Arch Linux, as I said previously. We use Dracut for our initRD because it's quite convenient, easily customizable, and it just works. We use Salt to manage our configuration and what packages are going to be installed on the machine or in the image. And then some custom tools, including Arch Creator, which is basically a script to bootstrap an image. So the first step is what you would do in any classic Arch Linux installation. That's packstrap a rootfs with some basic software. The second step we do is we install Salt. We actually have to pin this Salt version for a very simple reason. The current Salt version in Arch Linux repositories is broken, so we have to install our own. And then we have to patch system, systemctl, because the latest version of Salt doesn't support the latest version of systemd that's shipped with Arch Linux. So we actually have to hack the output of systemctl --version to remove that version and replace it with a version supported by Salt. Otherwise, Salt will just not start. Which is what we do just right here, Salt call, and the important part is this state.highstate. What that does is Salt is going to create Salt master, which then looks in a Git repository on the master branch and applies a configuration on your current system, which in this case is a rootfs, so we're inside a root right here. And then we undo our hack, we install some kernel modules, we generate our initRD using Dracut, and then we create a squashfs with everything that we've done just here. Okay, so this setup actually has a few problems. First, it's not reproducible for a very simple reason. Every time we start an image build, we don't know what packages are going to be installed because, well, Arch Linux is a rolling release, so they just release packages whenever they want. So we would just, install what's latest in the Arch Linux repositories. We could actually pin all those packages to a version, but there would just be too much maintenance for not much result. So we just hope that every time we rebuild an image, everything just goes fine. Salt is a pain because of what we've seen just before. It's also very hard to test the changes we do on these images. Right now we have two ways of testing changes. The first one is to push on a branch on our salt repository, build the image. We usually have an image called ArchLinux test for for this purpose. So once the image is built, which takes somewhere in between 20 to 60 minutes, we can actually start a machine using this image. Downloading the image, depending on where you are in the school, how good is your connection, can take between 2 minutes to 15 minutes. So you're in for about 30 to an hour and 30 before you can actually test your changes. So it's very hard to iterate on any configuration changes that you are doing. The second way we have to test changes is actually to commit on our salt repository on master, because of course, and then go on an already booted up machine and run so salt call state.highstate, which is going to query the configuration it should have from its salt master and then apply it on the system, and then we can test it, which is pretty fine, but again, pushing on master, not great. And you can test anything if you make any changes to a systemd unit that gets loaded on startup, you can test that, for example. CI takes forever, as I said, and we also don't have any packages cache, which is probably why the CI takes forever, because, well, we haven't had time to implement it, and as far as I know, it's not very much trivial. So there's quite of a running gag in our team that says, if we switch to NixOS, it's going to solve all our problems and everything's going to be fine.
Streaming has stopped.
Everything is going to be fine just right after that. And I actually decided to go and find out. So I mainly got inspired from the netboot configuration in Nix packages. And then what I did is basically hack on it. You can find everything here. The two things I needed to add on top of the netboot configuration was torrent downloading, which is basically putting ARIA2 in the init.rd and then launching the command here, and add boot cache support, which is basically checking if a partition exists. I do right here. If it does, you mount it. If it fails, we just mount a TMPFS so the image can still seed the torrent file. Right, you might wonder, how do I get the init file? Like in a standard NixOS installation, you would have a kernel command line argument called init that equals to something like /nix/store/ hash NixOS system /init. But the thing is, to add that in our current setup, I would have to have an API route on our service that manages images to update this path, and I just couldn't be bothered. So I did something that's a bit of a hack and frankly not quite satisfying. What I do when I'm creating my SquashFS, so the closure info, that's basically everything that has to go in the image. Store contents is a list that contains config.system.build.top level. So I have that. I have to put the NixPath registration also in my SquashFS. And then, for when the system boots up, I have to run nixstore loaddb and everything is in there. And then I echo config.system.build.top level /init. That's going to evaluate to something like /nix/store/ hash -nixos system whatever /init, which I put here. And I echo that in a stage2 init file. This stage2 init files end up in the SquashFS. And then in my init.rd, when I am done mounting everything, which means I have my Nix store mounted, And just right before I switch to stage 2, I actually export this variable, stage 2 init, which is the variable that's usually set when the stage 1 parses the kernel command line arguments. If there's init, it will set stage 2 init to whatever value is provided. And here I just set it to what would be in /nix/door/stage 2 init, which comes from here. There's a better way of doing this, actually. I would have to generate an IPXE script like that's what's done in the netboot module in Nix packages, which is actually the right way of doing it, and then upload that IPXE script also to our S3 where things get downloaded from, and our service that manages images, instead of providing a kernel and int.rg to download, it should just chain load on that script in our S3. I have to test it, but it should work, and it probably will be a better solution than this. So let's go over the list of the problems we had before and see if we solved some. Not reproducible. Well, Nix helps a lot with that, since we can pin our packages, which is the main problem we had before. However, my images are not yet fully reproducible. I noticed that when doing some tests to see if I could just upload an image on S3 even if it hadn't been updated, and some bits actually changed between the two images I built at separate times. I haven't had time to investigate it, but well, the only thing it adds up is that we don't have to have the manual step of going into our GitLab UI and start the job that uploads the images to S3, which we want to have anyway, so we just don't care about this. So we're pinning Nix packages using flakes, so we are only upgrading packages when we want. Salt is no longer a pain because we are now only using it to actually run commands on several machines across a computer room, and not using it to build a system anymore. So that's better. It's not hard to test changes anymore because you can just run a nix build config.system.build.vm and launch a VM, which takes about a minute, which is much better than the hour it would take you before, and you can iterate on hacking configuration pretty fast using that method. The VM is actually a bit broken right now because it won't accept my netboot configuration, but I just have to override that output and disable the netboot. But detail. We now have a CI which only builds the top level configuration and not what I call the netboot top level, which includes the squashfs, which takes some time. So the CI is pretty fast because it's only building a NixOS configuration. Some packages does not take a very long time. It allows you to have some feedback when you push on the repository if your configuration is valid and builds. The squashfs part of the build, which is what takes most of the time of the build, is separated into another job that's launched manually, as I said before, and also uploads the images to our S3. And we also now have a cache, binary cache that I set up in a few minutes, so we can cache our packages and our configuration. Now let's go over what that provides to our students, because what we've seen right now until then is what it helps us to do. But let's see what it allows our students to do. First, they can reuse the configuration. For example, our Kerberos and OpenAFS configuration is exported as part of a NixOS module in our Flake, which means they can import it in their configuration and use it from there. So they don't have to reconfigure all the servers and everything from their configuration. They can just use ours, and if we update it, they will be updated up to date with it. Students can also install the same packages we have at school, which means they'll have the same environment as they would have at school. which means it's also the same environment that's used between in the test when we automatically test their code to grade it. And then they can, so on the computers at school, install new packages. Right now, the only way they have is to download the source and compile it from there. Now, because Nix is multi-user, they can actually install packages. So what's done, as I said, netboot works, Kerberos and LDAP configuration, and thus OpenAFS support also works. I already have included some packages needed for development by the students. I think there's only Python right now. I have to add a bunch more, but that's for later. And the CI for the images deployment works too. What's left to do is some extensive testing, maybe via NixOS test. I've never used them before. I have to see how they work. Will they integrate with our workflow? And that's some more work left to do. I have to write some introductory blog posts for the students. I already wrote one explaining, like, from the very basics, what's a package manager, what's its role, what does it do, how does it do it, for a classic one, and then how Nix does it. I have to do some team training because currently in our team we're only 2 people proficient with Nix and NixOS. But if you want to use that in production and as a long-term solution, we have to train the whole team so they get on board and then know how it works. And then I have to write a small script to live update the images. So with Salt, you could do state.highstate, which you can't do anymore. So I have to find a way to update the images while they're running, which is pretty simple, I guess. And then what's next for this project? It will be on a 1-year trial, so the student can test it. They can provide us with feedback. And we'll see how it goes, and maybe we'll do a full switch to NixOS. And then the last item here is just some blue sky insanity from me. Maybe I would be able to somehow share the Nix store between all the machines in a room. I don't know how I could do it, maybe using IPFS, I don't know how that works. So if one student installed a package and another one installed the same package, they could just download it from the other computer instead of downloading it from cache.nixos.org. Right, and I guess that's all for me. If there are any questions, I'll be happy to answer them. If you let me just switch to the Jitsi room. They just rebooted. Yep.
Live streaming is on.
Okay, everyone, sorry about that. We had a little slight technical difficulty with like the stream and the Jitsi room being cancelled, but we ironed that out. So this now enters into the Q&A portion of this talk. And we do have I think 3 questions, 2 of which are actually from the speaker who's going to be speaking right up next. So first one is, have you tried to bring NixOS to the routers? Is there a plan to do so?
Sorry, to the router, you said?
Yeah, to the routers.
Oh, okay. So we don't have actually any plans for that. The only plan right now is to use it for the computers used by the students.
Okay, gotcha. And what kind of network setup does ePETA have or runs?
Well, I'm not sure. What do you mean network? Like, okay. So well, it's quite complicated. Basically, it's a mess. We have each computer room has a subnet. Our server room also has a subnet. The Bocal I spoke of at the beginning of my talk actually routes them for us. So I don't exactly know what goes on behind the scenes on their infrastructure because I'm not working yet. And then the only network we really have to do is the one in our server room. So that's pretty basic. Even though we have some weird stuff going on in forwarding between VLANs and all that stuff. I'm not sure that answers the question. I have my eye on the. Oh yeah, okay. I have my eye on the NixCon QA channel if you want to. Okay. Yes, there is isolation, probably, but again, that's not what we do. That's the job of the Bocal to do that.
Right, and someone just said you should not tell that to strangers on the internet. Okay, the next question we have is, what and if there is CI, what is it and is it being used?
So we're using GitLab CI because that's what was used up until then. We're not really planning to use Hercules or Hydra because well, that just doesn't fit in our workflow currently. I'm not quite sure there's a way for them to automatically upload the outputs of builds, like not the path in the Nix store, but actually what's in it. So I don't want to, when you Nix build, you have a results symlink. I don't want to upload what's behind that result symlink, but I want to upload only results / let's say nixos-test.initrd and nixos-test.squashfs and nixos-test.kernel. I want to upload these 3 files fully to R3 with the same name. So I actually change my my image. So we're not currently planning on any Nix-focused CI system.
Right. I've used Cachix for some things like that. I'm not sure if it's entirely possible to do what you're doing though. It might be worth looking into maybe momentarily. Okay. So I don't think I see any more questions in the channel.
Right.
Yep, I think that concludes the Q&A session. Thank you so much.
Thanks to you.
Yep, and everyone, you know what to do, and the channel, come on, show it out, show the love. We gotta keep it going. And I think we're short on a break because of the Q&A session, so I will actually jump out of here and do that as quickly as possible. Okay, sorry, I kind of got kicked from this room. So we have our final talk of the conference today. Well, we have a whole other day tomorrow, but yes. Our final talk is Nix in the Java Ecosystem by Farid Zakira. I hope I'm saying her last name properly. Java is one of the most popular languages. However, there is a fragmented and incomplete solution when it comes to tooling available by Nix packages. This talk is going to go over the current state of affairs, so you know what's available today in this situation, and what is so difficult about Java compared to other supported languages inside Nix packages. And there's also going to be greatly a proposed solution aimed at filling this gap. And just some information, hopefully is not going to be embedded in the presentation, about Farid is he's deeply passionate about reproducibility, developer tooling, and ergonomics. His prior experience has largely been centered around building public cloud infrastructure for AWS and Oracle. And he has over a decade of experience writing software, is currently employed by Google. And I guess you could say outside being a software engineer, he is a father and a wishful amateur surfer. Okay, take it away, Farid.
Am I live? Can you guys hear me? Oh, I'm live. Oh, thanks. So thanks everyone for attending. I can hear you. I'm presenting from OBS, so I'm gonna just continue. I think I'm live. Okay, I'm gonna start. Oh. Okay. Sorry, I muted this thing. I was just presenting over OBS my audio. I'm gonna start. Great. Thanks everyone for attending my talk. Just to recap, my talk's gonna be geared at Nix and specifically in the Java ecosystem, and I'm gonna center it on Maven. The subtext for this talk is making Nix enterprise friendly. The subtext may be where all my Java peeps. And I'm gonna show some slides with some code samples. I just wanna, I guess, apologize ahead of time for that. So I had a little nice introduction already, so we'll probably go really quickly through this slide. I'm Farid, it's Zakaria, that's okay, no worries. Currently working at Google, again, about a decade of experience, probably 9 of those 10 years on Java. Relative newcomer to Nix. I heard a great quote on the Discord channel, endless beginner, that I thought is quite apt, unfortunately. And the range of build support for Java code bases at the companies I've worked on have ranged from like off-the-shelf Maven and Gradle to highly custom proprietary build tools. And, you know, so I'm a pretty happy acolyte at the moment with Nix. It's a Pandora's box I've opened, and yeah. So the goals outlined in this talk are, I'm going to describe why we should improve Java support, how other languages currently offer support in Nix, the main pattern or strategy, and kind of what's challenging with that in the Java ecosystem. And, you know, hopefully a goal of this talk is to empower you to use Nix for Java at your place of work and solicit more improvements and ideas. So maybe get people who are using Nix and Java out of the woodwork, and let's collaborate some more. So why am I singling out Java specifically for enterprise? Well, Java to date remains a very popular programming language. Here's a snapshot of the top 10 languages by popularity of their Google searches. So Java, you know, as of 2020 is second, but up until recently it was #1 for quite a while. And my subjective experience, however, is that Java remains one of the highest in demand languages for non-Windows based enterprise shops. You know, building web services are Java's bread and butter, and So I think there's a lot of opportunity there to build upon. So I'm making the claim enterprise loves Java, specifically non-Microsoft shops, because they have .NET, which is C#, kind of very similar. And in fact, Java's enterprise notoriety has made itself memeable with its overuse of design patterns. So this graphic here is just like a little excerpt from, and it's really funny, I put the link. I don't know, it gives me a chuckle. It's a really fun implementation of the FizzBuzz interview question. So if you're not familiar with FizzBuzz, the question says, just iterate from 1 to 15. And if it's divisible by 3, output fizz. And if it's divisible by 5, output buzz. And in classic Java fashion, it's overlaid with strategies and factories and patterns. So yeah. And the top there is like also a really fun class name that you get in Java a lot because of the overuse of patterns and strategies. So it's like factories of factories that are instances that are beans. So many languages nowadays have an accompanying tool to help manage and resolve dependencies. So pip, cargo, bundler, maven, cabal, npm. Dependencies are no longer vendored along with the source, and there's an expectation that you have some network connectivity to rehydrate those dependencies. Unfortunately, Nix build sandboxing disables network connection, for good reason, to try and force reproducible builds. So, what can be done here? And maybe, the simplest Nix derivations shows that, and that's fixed output derivations is the solution to this problem. The basic formula that many languages with support in Nix do is they take their custom lock format, generate a Nix expression. So this is the Nix language support. One step is here. So it takes the lock format file, generates a Nix expression. And then there's accompanying Nix support to take that Nix expression and use fetch URL to download all those dependencies and bundle them all together in a single Nix store entry with link farm. And ta-da, we have our vendor directory back. This works because that Nix expression contains the SHA. So fetch URLs allowed to proceed in the sandboxed environment. Okay, so I'll go pretty slow here. Again, sorry, I know it's like a bummer to see code and text in slides. So just to put it in perspective, here's the contents of a popular Nix tool for Ruby. It's called Bundix. So on the left is my gem file lock. So that's your lock file that pins your transitive closure of your dependencies to specific versions. Bundix takes that on the right and generates a Nix expression, or really anything native to Nix would work fine. So many tools use JSON. You can see here it tells you where to download it from, as well as the SHA, which is important for the fixed output derivation. What's not shown here is the call to generate the final Nix store entry, but I've included it here, and you can see it's a link farm of all those downloaded dependencies. And with that, you can now pass it to your language of choice. In this case would be Ruby, and you have your vendor directory essentially and all your dependencies. What's really nice about this pattern is it's pretty granular. So because we're using Nix link farm, all the dependencies have unique Nix store entries, so they're reusable, and because they're at a particular version, but it's somewhat pragmatic because it's a flattened tree. So you're not getting the full transitive graph, which would be kind of neat, so that you could use like Nix query, Nix store query to see even your dependency tree from your language in the Nix store. But I think this is a good middle ground. Okay, so enter Maven. So Maven was released in 2004. So I think Nix is 20 years old. So not quite as old as Nix, but pretty old still, 16 years. It predates many newer languages and package managers. And it has still a huge market share. I'd say Java is predominantly split between Gradle and Maven. I'm not really sure which one's the dominant one. Subjectively, for me, it's been Maven. It does things different than what you might come to expect from more recent package managers. And I think the most important one is it does not generate a lock file, which is interesting. It relies on the fact that the algorithm with which it walks your dependency tree is stable and explicit. So the same versions are always resolved. And it uses a nearest wins strategy. So as it's walking your graph, if you have a diamond dependency problem, so two different dependencies depend on the same library, but at different versions, during the nearest win strategy, whichever one it hits first is the one you're going to resolve to. That's, I guess, kind of, it's interesting because then it doesn't have to do any SAT solving to find correct versions that work within ranges. The problem, though, is now adding dependencies or even bumping anything or changing anything in your transitive closure can really change the graph and have reverberating changes to the dependency versions. And then there's the fact that Maven is closer to Make rather than some of the other package management tools because it's really generic, and you can plug various plugins to augment your build lifecycle in any sorts of way, in any way. It's in XML, so it's quite verbose and kind of challenging to also work with. So, what are the challenges I see with Maven and Nix today, and incorporating Maven into Nix? Well, for one, it has some APIs externally to investigate the dependency closure. So, and this would be useful for writing a tool that generates the Nix expression or JSON, but it's somewhat restricted and actually pretty incomplete. So it has a rich ability to generate plugins for itself and offers substantial flexibility there. However, any external tooling is lacking. The current API they offer lets you introspect, compile, or runtime dependencies, but you excludes all those build time dependencies that are useful for plugins, which you still need to run Maven in a network isolated environment. And like I said, it's a pretty generic system. So really trying to capture a really good one size fits all solution is challenging, especially since it's used a lot in the enterprise world. They're more likely to have some bespoke use cases where they're really doing, interesting patterns. And I mean, I think that's also why it's so popular in enterprise, because it can really do anything. Finally, there's some anti-patterns that are really popular in Java that are kind of antithesis to how Nix wants to do things. So when you wanted to distribute a jar or your application, it was really popular to build what called a fat jar or uber jar, which is I think a good analogy would be a static binary. So you're bundling all your dependencies together in a zip, which is what a jar is. You can't leverage then a lot of the granularity and cacheability of Nix through the store. And finally, there's just not a lot of documentation or examples in Nix packages, maybe likely because a lot of it's closed source, and this is what my talk's geared at. So augmenting the documentation, showing how to do it today, and getting people to contribute more openly. So I want to talk about two patterns of how to package Nix really quickly. The first is the double invocation pattern. Actually, it's not really specific to Maven. You could use it with anything, but it's quite useful here. I actually came across this pattern in a GitHub issue, which is somewhat, I guess, typical with how you come across solutions for problems at the moment in Nix. A lot of Googling and reading through GitHub issues. You run your full build, which would be this top part here. This whole derivation is running the first build once. And Maven repo local is where it's going to be building out the cache dependencies locally, and I'm setting that into my Nix store. There's a little cleanup phase here in the install where I'm just removing things that help to keep the output hash more consistent. so like timestamps and files that Maven wants to generate. And it's double invocation, so you run this once, you kind of fix up your output hash. So you put a fake output hash to start, tells you the output hash you expect. And now the output of this derivation I could then feed into a subsequent Maven build and tell it to work in offline mode. So I could use this NixStore path to basically rehydrate a subsequent build. You know, surprisingly, this isn't bad, and it works in practice pretty not bad. However, you know, due to the lack of a real log file and ways some people choose to structure their Maven application, so using version ranges, or unfortunately the use of snapshot, which is a special type of development copy, so it's not pinned to an exact version, you really run into the problem where the output hash is not reproducible. So submitting this into something like Nix packages may not be optimal because it might get out of date and be unbuildable pretty quickly. Finally, it's not very granular, as it's downloading all the dependencies within a single NixStore entry. So subsequent rebuilds of this derivation have to essentially re-download always all your dependencies all over again, and you have these pretty coarse store entries. So here's actually using the previous Nix build invocation, previous derivation. So here I actually set the repository, which would be a variable set to the previous derivation. And what's important here is I'm telling it to run in offline mode. And yeah, we're off to the races there. So there is actually some, you know, air quotes here, official support in Build Maven, language support for Maven in Nix packages, and it's called Build Maven. It relies on a Maven to Nix plugin, which I've included here as the source, link to the GitHub repo. Put it quote unquote official because, and what spurred this talk is there's very little recent activity. So the last commit was 2017, and I think there's some improvements to be made that I'm submitting, as well as, you know, lack of documentation. But it tries to fit in this pattern that we see other tools doing and language support. So it does generate a log file, and it uses the link farm pattern. But it only goes as far as actually generating a jar, so which is your library. But if you're a service author or an app author, you know, you want to get to a runnable artifact. Okay, sorry, we'll go through this really quickly. So maybe just to show how intricate Maven is, I have a screenshot here. The POM XML, this is like package JSON or something similar in other languages. This is how you define a project. This is like the most empty project you can write. I just have the name of my project, no dependencies, nothing. I then take this and use Maven to Nix, that plugin, to generate the lock file, which they called projectinfo.json. And what I thought was great, and what Nix is great, is making you hyper aware of the dependencies you need to build that were so implicit. So just an empty project here has 257 jars and 640, you know, items essentially in my Nix store. So some other metadata. Like that was kind of eye-opening for me, like what you need to just start off with an empty project. Kind of the bottom photo here shows that link farm it's building. So it's, oh, how do I get rid of that? It's still following the pattern of other language tools. So it's still kind of flattened and pragmatic. It's just one level deep tree. This is like a pretty good pattern I wanted to share. So if we wanted to make the jar actually runnable, it's pretty easy to do this. So in Maven, jars can self-describe their class path, which is very similar to like where they load their libraries from within the jar itself. And Maven, you can augment it with a plugin to modify that file and dictate the dependencies. So all you need to do here is put a little snippet like this where we're saying add the class path for all the dependencies in my project. The prefix is going to be lib relative to where the jar is, which is great because we want it relative to the Nix because it's going to be in the Nix store. And the layout type is actually repository, which is also great because that's the Maven repository layout format. which we had already built to actually even build the jar in the first place. So all I do is you take that repository and you link it into lib and copy your jar out, and I make a little wrapper to run it, so you don't even have to, you can just run a little script that starts up your jar and it loads up all your class path, and you're in business. I guess the little downside at the moment here is I've added quite a lot more than I need to my class path. So I've added all the libraries I need to actually build the jar. So there's some improvements here to slim down the repository down to just what you need for runtime. So kind of looking forward, I love to meet and contribute with others working on Nix and Java. I showed earlier how popular Java is, so it's surprising to hear so little of the community. I mean, I think Nix is great in having a really vibrant Haskell community and some other languages, so I'd love to see something align more with how popular Java is. This is kind of just the surface, and I'm only covered Maven, but the Java ecosystem, or I guess JVM-based languages, are pretty fragmented. So there's Gradle, SBT for Scala, Lanigan for Clojure. So what's a way to build a really cohesive story around all these tools that work together? I mean, because fundamentally they're building jars and they run the same way. I think there's an interesting opportunity to also build patterns that use JLink. So that's actually a tool that, rather than having to distribute the whole runtime for Java, it builds a small runtime image, native image, which would be pretty cool. And, you know, help me out and look for other contributors. I'm adding language support documentation for Maven and Nix packages, and we'll continue to help improve the story here. And I just so that's my talk. And I just wanted to thank the Nix community, the NixCon committee, for kind of making all this possible. Thank you.
Yep, you are very. I definitely appreciate that. Okay, it doesn't seem that we have at least one question for you. Okay, the first question will be. I'm getting a really bad feedback. Very disorienting. I'm sorry. I will try to make do.
Hi.
Okay, it's from NixNut. Any experience with Gradle and Nix? I guess this is a question.
I haven't yet. I was looking into it to try as I'm adding documentation, and I actually see that Gradle has a plugin to generate a lock file, which I was making the claim Maven doesn't natively. So I actually think the story here will be much better. But there's the second half. So there's building your Maven repository, because that's what all these JVM tools still use. Doesn't matter what the top tool is. Many of them rely on the Maven repository layout and like kind of federated way to distribute packages. So unifying that like final piece of building the jar and runnable is what I'm interested in as well.
Okay, I'm sorry. The feedback I was getting is no longer there, so I can pick up again. It was like being disoriented. I'm very sorry about that. So I don't believe we have any more questions for you. So thank you for your talk very, very much. Yeah.
Yeah. Thanks, everyone.
Yep.
Appreciate it.
And with that, this is the sign off, everyone. Thank you so much for watching, participating, you know, speaking with the speakers in the breakout rooms, all of that. It really is meaningful and important that we were able to do this in an online setting in this way. So yeah, I would just like to, even though we thanked them so many times, the viewers, thank you. My organizers, oh my gosh, thank them so much. These are miracle workers, I'm telling you. Really, really are. Like, this is magic, actually. This is completely magic. So yeah, I feel fab. Everyone have a great morning, afternoon, evening, wherever you are on the planet. Yeah. Goodbye. Thank you. See you tomorrow.